have a smart contract that maybe is calling another smart contract in another chain and then coming back and transferring values between one chain and the other. And ideally, this should be done fast in a way that from the user perspective, it should be seen everything like as a single network. Okay, and for doing this, the main technology that enables this is the ZK technology. So this, of course, another way to see this is like I like to talk about the similar about processors. I mean, here there is like two ways to scaling processors. One thing is doing processors faster, but the other is setting more cores as a processor. So of course, each chain, there is a technology to make this chain faster, but at some point there is some limitation, and then the way to scale is having many processors, in this case many chains that connect and that communicate one with the other. Here, of course, we are talking about a trustless, a trustless bridge in a thing that it doesn't depend on third parties and things like that. Okay, so. Yeah, this is the main advantage. I think that from the user perspective, this can be super interesting. I mean, imagine, for example, I don't know, a private network of some corporation talking maybe with another insurance company and doing some swap in Uniswap chain, or just there's composability between chains. This, here we are enabling for the people that's out in the space. This reminds me a lot at 2015 or something like that, when we were talking in Ethereum about sharding. At that point, we didn't distinguish between data availability and everything. I mean, shards were just execution environments at that point. And we start talking about this cross-chain, these asynchronous calls, cross-chain communication, or in this case was cross-shard communication on that. This is the equivalent that we have right now. So now it's time actually to put all that theory that appears in 2015, 2016, and put that in practice. Okay. So the first step is what we have. This is the LXLY bridge. Okay. So in order to understand how this aggregation layer works, we need to understand how the bridge works. And what's the idea of the bridge? Okay, so let me explain briefly how a bridge works. Okay, if you have different chains, and you can consider L1 as another chain, maybe it's a special chain, but at the end it's another chain. Every time that a chain wants to transfer funds to another chain, actually what we call we have a kind of a database, or if you want a Merkle tree of exits of that chain. We call this local exit route. Okay, so you have a chain. Every time that we do the transfer to another chain, we add a leaf to this tree. Okay, and in this tree is an append-only tree, so you see only the different the additions to those trees. Okay, and here the idea is that we collect this root of this local exit route. Okay, in mainnet, and we create another root of all the trees. So it's a tree that aggregates all the trees of all the chain, and we call this tree the global exit route. And this global exit route is actually broadcast to all the networks. So the idea is how it works. You send funds to another chain. You send your funds to a smart contract. This smart contract actually updates the tree, the local exit tree. This local exit tree, when the proof is generated, it's inserted in the global exit tree. The global exit tree, it's sent to the other chain. The other chain already have this global exit tree, and then in the other chain you can claim those funds because you can prove that the exit in one side is in the global exit tree. And in general, you also mark that this, in order to not double spend or not do that, so that you can only claim once, you mark that as a claim. Okay, but see, yeah. This is very much how the local exit tree would look like. Okay, this is the kind of the leaves that you can see in there. Okay. So, this is actually what's running. We already have some private chains connected to the bridge since the last week, but this is relatively slow. Why? Because Well, when you do a transfer, the other chain cannot start using the funds until it's sure that this local exit tree is propagated to the global exit tree, and this global exit tree is actually included in the state. And for that, I mean, this is a slow, but because I mean, the idea is one chain. When you're sending some funds from chain A to chain B, well, you need the chain A needs to generate the proof and publish this proof on layer 1. At this point, then you are sure that this global exit route is updated, and then you can use it in the other chain. Generating a proof currently, it's a process that takes a couple of minutes. This can be reduced. I think that can be reduced to a few seconds with technology. I mean, with improvement of the ZK technology that are coming. But in any case, there is this L1 transaction needs to happen, and the chain needs to publish this transaction. Okay, so this is the first approach. This is what it is right now. It's good because we can communicate different chains, and this is the first stage. But we can do it better. Okay, so what's the next improvement? Okay, and this is not ready yet, but it's almost ready. We are auditing the smart contracts. The idea is that in the CDKs in Polygon, instead of each chain creating their own proof and publishing their own proof and paying the cost of the proof, the idea is that one proof rules it all. I mean, the idea is take all the proofs of all the chains and aggregate all the proof to a single proof. Okay, and this proof, and then when you publish this proof, is a proof that's it's proving all the chains. Okay, so it will not earn directly speed because it's exactly the same. You need to prove, but the idea is that the cost of the proof is going to be much smaller, and because this proof is aggregated to all the chains, we can send this proof more frequently. So we can send maybe this proof once every minute, 2 minutes, or every 3 minutes, because it's a proof that's common to all the chains. Of course, the chains can do the proof individually if they want, but if they send the proof to this aggregator and then this proof is aggregated, then this is going to go. I mean, we will guarantee that this proof is more peaceful. And this proof is. It's like a clock. I mean, this proof is what actually triggers the transfers. Okay, because in this proof is when we take the global exit route and we send it and broadcast to the other chains. And this is like a clock for all these transfers. Okay, but for this we still need to wait for the proof generation and the clock. Okay, so what's the next stage? Okay, and this is mainly the core of the aggregation layer in the future. Okay, the next stage is the idea is to have a blockchain or something similar that's a kind of a coordination blockchain. Okay, and the idea here is that the chains can commit to a given state. Okay, so and okay, they commit to this when the chain commit to one state, the chain cannot change this state. So the other chains now have the warranty that this state will not be modified, and the other chains can start using this in the local exit route, or the state of this chain can start using that chain. What are the conditions that that the other chains? What conditions are required for the other chains to accept this? Well, the first is, of course, that the state is committed, and the second is that the second chain is able to generate the proof that goes to this state. So actually, it's not necessary to generate the proof. If another chain is able to generate the proof, maybe because it's following the other chain, they can start using the other chain. Why? Because the state of the other chain is committed, and if the other chain doesn't publish the proof, you can always build the proof. So the other chain can build the proof. So then this guarantees that I'm not going to be locked. So what's the problem? I mean, what the bigger problem? Let's explain it in a different way. Okay. So imagine that we have a chain A and chain B. Chain A commits to the state 1, to A1. And then chain B commits to B1, okay, but the chain B requires A1 to. I mean, it depends on A1, okay. So it's using the local exit route of A1, okay. So if the state A1 is reorg or it doesn't change, then B would be locked for that. So when chain B decides to include A1, to depend on A1, chain B needs to have the warranty that's able to prove the A1, and that A1 have the warranty that chain A will go to the exact state route that chain A1. Okay, so and this chain, of course, you can commit to different chains. Later on, you can prove the different states, and the proof you see here that there is a kind of a dependency tree between chains. I mean, maybe the state A1 depends, so the state C1, for example, depend on B1, but the B1 depends on A1. Here there is if you can see a graph of dependencies. So the state actually, the final state becomes only valid when all the dependencies are solved. Okay, and this can be computed dynamically and proved dynamically. At this chain is going to be also a kind of a checkpoint, so points where you will take this state, and the aggregated proof will be computed. It will take all this individual proof, and this aggregated proof will be computed, and then send it to layer 1 just to consolidate the state. And this can be done, again, once per 1 minute, 2 minutes, 3 minutes, or whatever. But the cool thing here is that the cross-chain communication can be solved really fast. I mean, here we are talking about seconds. If this aggregation chain has a finality of 2-3 seconds, that means that in 10 seconds you can do a full composability between different chains. Okay? So this is this is very much the core of the aggregation layer. Here, I mean, there is a lot of details, about these dependencies, the proving, the aggregation of the proof of all this. But this is the main idea, okay? And from the user perspective, I think it's interesting to see that how we are solving this fast intercommunication layer in a trusted manner. Okay. Also, this chain can be used. This chain also can be used also to decentralize the prover. Because this proof, anybody should be able to generate the proof. And in this chain, we can create all the cryptoeconomics for the proof generation. So that instead of being a central server that's generating all the proof, different chains or different actors can generate the proof and get reward for that. And this is the chain that will coordinate the proof aggregation of this. Okay. And just to finalize, I'm a little bit changing a little bit here. I just, as responsible of the ZKVM team, here I want to explain the roadmap. Of course, there's no strong commitment, but this is, I think, it's good in the conference to explain what we are doing inside the team, and this is, and what you can expect in the upcoming month. Okay? Right now we are. Fully working in the EIP 4844. 4844, it's for data availability, is going to be a super important EIP. This is going to be enabled next month in the mainnet. Okay, and so we are working, and we expect to already be using EIP 4844 at the beginning of May. Okay. And then we will work with data compression. Okay, so these are the big things on that. In parallel, we're also working actively in the Erigon integration. So this will increase a lot the performance of the ZKVM, because the main client is going to be Erigon. Here is the RPC and the sequencer that we're working a lot. And then in parallel, we're also working in the technology in the VATCOPS PIL2. This will allow us to remove the counters. This is a ZK counters as a specific thing of the type 2's rollups. But this is, most of the users should not care about, but there are some DeFi applications that currently it's a little bit difficult to handle that, and the idea is with VATCOPS to remove all these counters, and also increasing the performance of the prover. We expect, we don't have current numbers but we expect that 2x, 3x improvement on the proof generation will happen in the VATCOPS. Data compression, again, in the data compression, we expect that the cost of the full ZKVM should be something like between 5x and 7x compression, and this is going to be very much the cost. in parallel, right now, as I mentioned before, we are onboarding the CDKs. The first networks are already live on mainnet, and we expect to the next weeks and month to start onboarding different CDKs. Different chains. I think here, even from the business perspective, is a super interesting opportunity. The CDK, it's a sovereign chain. They can have their own token. They can get all the fees. There is a lot of new opportunities for the new reward. New monetization models that can happen because if it's a centralized sequencer, you can get all the fees. You can centralize, decentralize, going to Validium to no Validium. So here, the vision here is that all the dApps, instead of having to create their own layer one, that's what they were doing. Recently, the idea is that they can just run a layer two, their own network, and that's going to be much easier, and they can focus in the specific application. This is the concept of dApp chains, or there is a lot of opportunities here on the CDK worlds. Okay, and of course, we are also starting to work on this aggregation layer, what I presented here. The aggregation layer V2, this aggregation of the proof aggregation of the different circuits. This, I would say that the proofs and the proofs and the smart contracts, they are done. So this probably we are auditing at that phase. So I hope that in, I don't know, 1 month, 2 months at most, they're going to be available, and we are start working hard in this aggregation layer in the V3 in this chain to do this coordination between proof and actually go to the few seconds cross-chain composability. Okay. And that's very much what I wanted to explain. Thank you very much for listening to me.
Check, 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 check. All right, good afternoon, everyone. Thanks for coming out. Our next speaker is going to be at 10:50.
be on. It won't be on. So the, oh, it is on. We got 5 minutes. Hello, test, test. Good to go? All right. Hey guys, thanks for coming to my video talk. I am Terrence. I am from Off-Chain Labs. I am an Ethereum protocol developer.
And today I want to talk about what we're working on 2024, and most of it on my personal opinion. But yeah, I'm happy to share with you. So quick poll, who here runs an Ethereum node? Whoa, that's a lot of people. That's awesome. Yeah, I won't ask if you run a validator because I don't want to doubt you in public. But I presume if you run a validator, if you run a node, you probably run a validator, and you probably know what like Prism, get this, and stuff like that. So yeah, so today I want to talk about like what are we making on the client side improvement, and what is Ethereum upgrading to after DNAP. So first, I will start with client code improvement that we are making on Prism. Again, some of this are my personal opinion, doesn't reflect the overall team, but I think there's a high degree of chance that this happened in 2024. So first, what is Prism? So Prism is an Ethereum consensus layer client written in Go. So how Ethereum works today is that you have your consensus layer client, like Prism, Lighthouse, Nimbus, Teku, and you have your execution layer client. So as you know, when you run a node, you are essentially running two pieces of software, and both software communicate with each other using the engine API. And if you run a validator, if you're validating, you also run a validator client on top of your beacon node for signing. Well, the validator client are mostly lightweight. And what is a beacon node? What is this Prism client, right? So it's this consensus client, and it has this P2P stack. It has this REST server for if you want to query your validator balance, you want to sign block, and then it has the persistent DB. And for Prism, it also comes with a slasher, but that's optional. That's to detect cheating that's happening on the mainnet, blah, 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 right? So that is a very short form of what the Prism is. So what do you care about when you're running a node? Obviously, like if you're running a validator, you care about performance, right? Because like if it performs poorly, that you lose money, and losing money is not fun, right? And how do you lose money? You could miss a block, you could miss a attestation, and some of it may not be your fault just because of, okay, you may have a slower internet at that time, or maybe you're sharing your Prism node or your consensus layer client with different services that's running on the same computer, and then the memory spikes out, blah, 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 right? So there are a lot of factors that goes into running a node, right? So I will label the first one is performance. The second one is that if your node is using so much resources, that it's also not good, right? And the resources consist of bandwidth, memory, storage, and compute. And those are something that, like, as a client team, we are always optimizing. So today, Prism. So this is captured on my mainnet setup, right? So I have a nuke. I have a CPU, which is pretty decent. I have 32 gigabyte of memory, 2 terabyte of SSD. You can purchase that today for about like $800, so it's not like very expensive. And I have 100 megabytes of download, upload bandwidth, which is still reasonable, right? And to process a block, meaning that for the block to arrive and then I process it, it takes about worst case scenario, it takes about 1 second. And then on the get, it also takes about 1 second, worst case scenario I'm talking about. But then luckily, both of them are processed in parallel. So typically, when you process a block, we say the worst case is 1 second, right? And what does this number matter? Because today, a slot time is 12 seconds. You receive the block. You have about 4 seconds to verify the block. If you exceed beyond that 4 second mark, it's likely that you will miss the run. You essentially vote the parent block or the current head that's not a block, and likely chance you may vote for the run block, or you may try to reorder the block. So it's just not ideal. And today, Prism takes about 6 gigabyte of memory. Jet takes about 3 gigabyte of memory. And then the disk space usage is about 1.5 terabyte. So now the question is, can we do better? The first improvement that we should be starting seeing is that we have tons of caches. And when we started writing the code in 2019, that I think like we did not foresee like what happens 5 years down the line, right? We don't have enough knowledge when we start writing the code. So we have a lot of caches that essentially serve the same purpose, right? And then beacon state, the state itself is by far the biggest object on a consensus layer client. So now you have different caches that may serve different purpose, but there is overlapping responsibility that you may able to reuse it. So I think the first task that we should be focusing on is essentially to consolidate the caches to basically to the few that we mandatory need. And that this will significantly improve the memory allocation. The second thing is that we want some sort of constant size DB database. Just us for now, the DB grows linearly, right? We store every single block since the genesis. We don't store every single state, but we store state at some checkpoint. And with a block, you can replay the state to any different times you want. So that's the power of replaying the state through the block, right? But do you really care about some block that's 4 years ago? Probably not, right? So you kind of rely on this blockchain altruistic identity that you only need one single honest node to serve you the old block, right? Not every node has to keep every single block from the genesis, right? And even today, we have this our beacon chain spec that defines that we only need to serve peers that with a block that's 4 months old, right? So we can start actually doing that. Today, at the Prism node, by default, you can prune every single block beyond the 4-month period. And you probably save a decent amount of storage. That's something that we can done today. And it's something that I think we probably will focus on this year. Then again, this is validator minimum slashing DB. So right now we have our validator, it signs things, and then if you double sign thing, that's a slashable offense. And that is really bad. You don't want that to happen. So to protect that, validator has this slashing DB. And in the beginning, that different client team implements their DB differently. They have their own slashing format, right? But then in the recent years, there is this EIP to essentially define a format, make it interchangeable between clients, meaning that if today you're running Lighthouse, you want to switch to Nimbus, you can actually import the validator slashing DB on the fly, so that they essentially reduces the risk of you getting slashed, right? So this is something that Prism team has been working on, and then and something that is really useful. Okay, so this is something that we get asked probably the most is that when REST-based validator client. So in the beginning, we spent a lot of time focusing on gRPC as a protocol because of the REST standard wasn't defined. And then the REST standard defined after we start implementing that. So as of today, Prism validator clients only uses gRPC, and then it connects to beacon node using the gRPC, right? But you can tell this kind of hurts this interoperability because a lot of the different client teams, they all support REST, which all of them support REST, and they have their REST validator client, right? So it would be nice to have the same standard, use the REST validator client, so such that you can have this interoperability, and then the performance should be as comparable to the validator, the performance should be comparable to the gRPC. That's the important part. So once we switch to REST-based system, we can actually deprecate gRPC. That's a lot of code cleaning, code health improvement, right? So we can deprecate gRPC service, we can replace all the protobuf stuff, reduce upstream dependency, and then in some parts, you will also improve the performance as well. That's something that also the code base will be more welcoming per outside contributor. They just want to work on Go. They don't really care about protobuf. They don't really care about gRPC, and then they just want to write Go. And that's also welcoming as well. That's something that we are very much looking forward towards. Again, right? Without saying there will be UX improvement this year, we'll have better alerts, better docs, better monitoring experience. We're also working on simplifying the web interface. So everything above what I said was more of the client-specific improvements. So now I want to talk more about Ethereum-based improvement, which we actually implement the protocol. So these are the protocol changes that most likely to come in the next hard fork. Okay, so here are some EIPs that were more bullish given the timeline is say Q4 2024. The first is the EL triggerable exit. Okay, so let's go back to the beginning, right? So I said that when you run a node, you run two pieces of software. That you have your beacon node, you have your EL client, get or whatever, right? So the separation concern is nice. And we can actually take advantage of that, right? Because now running two pieces of software, they can allow to pass any message. So as a beacon node, I can learn what's happening on the EVM world like really fast, right? So one thing I can do is that I can pass message for validator exit through the execution layer. And this is very nice from the standpoint of, say, a staking service or a restaking service, right? Today, to add to your validator, you have to sign something on the CL layer, but your EVM contract does not have access to that to signing that thing on the CL layer. That is a trusted operation between the operated node, right? And that kind of hurts that trust when you talk about like eigenlayer, when you talk about restaking. So you'll be very nice to essentially to be able to trigger the exit on the EL. And I think this is a big win once we get this through. The same thing that goes for deposit as well. So I was talking about exit, but now it's a deposit. It's the same thing, right? You can have your EL directly send the CL client what the exit should be. So currently how it works today is the CL are actually like listening to this like deposit contract through some ETH get log event, and they have this 8 hours delay for withdraw. But this simplifies the process, right? We can trust EL just in time. So EL tells me that there is a deposit that's happening 10 minutes ago. We can already import that. And then it also allows us to clean up the code base a little bit. So we can deprecate all of the ETH1 voting logic, blah, blah, blah. The third one is that this is more on the attestation structure. So attestations of votes, they're validator voting on what is the head of the chain. So we can change the attestation structure to make it more aggregation friendly. So this helps network propagation. It will save you bandwidth. And then in the happy case, your validator may make less vote correctly. So again, this one's interesting. This one's reusing the validator indices, right? So today, when a validator exits, the validator still exists in the beacon space, right? So that space is wasted. You basically have this like 50 bytes that just stuck there, right? And right now there are about like 200,000 quantities of validator that's exited. So that space is just wasted forever. It seems silly, right? So it would be nice to essentially repurpose those validator indices for the new validators. So this seems to me like a no-brainer. So there are some EIPs that's very interesting, but then we want to do it, but we're kind of like less confident given the Q4 timeline. But this may be more confident if today we say the next hard fork is in Q1 2025 or Q2 2025, right? The first one is peer dust. So we know DNAP is coming that enables some sort of data scalability. So now we can have another data market for blob data. So peer dust kind of takes it to another level, right? So instead of like every node stores everything, that we essentially shard the data, and now every node samples the data. So every node doesn't have to store everything. So this is getting close to the end goal of what we want with the scalable data, because we don't want every node to store everything, right? And this is, so we're essentially take what we have in EIP 4844, we construct that into different columns, and every node just have to sample different columns. And then force inclusion disk. So this is another interesting one that we want to address sooner or later. It's currently like a number of blocks that are getting censored, and then as a solo validator, I have to make this choice whether I want to use the builder or I want to build my local block. But this choice is hard because it's saying that do I like money or do I not like money? And most people will probably say that they like money, but then they ended up using the builder, and then you basically have to build the blocks what the builder gave you, right? So force inclusion is basically give validator this option that says that you can use the builder still, but you can still propose your own block but those block has to be included by the next validator. So this improves censorship resistance over the network, which is very important for the credible neutrality standpoint for the long term. Then there's a bunch of proposals that me and my team have been working on. That's ensuring proposal builder separation. So currently you have your validator, you have your builder, you have your relayer. And relayer is this trusted entities that's in the middle between the validator and the builder. And then we think there is a nice outcome that we could achieve by removing the relayer and then ensuring some trusted communication between the builder and the validator itself. But this is, of course, this is like at least a 2-year project, in my opinion. It requires a lot of thoughts, but I think this is the angle that we should achieve, because the current MEV boost, the relayer world, may not be sustainable for the long term, and I think this vision will serve us well. Finally, right, there are some initiatives that we plan to explore, such as max effective balance. So today, every validator 32 ETH, and then you have 100 validators, then you deposit 3,200 ETH, but you have 100 keys. So you're propagating 100 messages over the network, right? But that's quite wasteful. Why can't I just propagate one message, presuming that I have 100 keys? That's what max effective balance is, and it's something that we would love to explore. The second one is Vertical Tree. Vertical Tree is very interesting. It's mostly changes on the EL client, less changes on the CL client, but we will be happy to support that. This this essentially ensures more trustless verification on the EL side. We can increase the guess limit, and then the lighter node can also verify the block through some sort of proof. So vertical is definitely the future. And then light client roadmap, definitely. Light client has existed for a long, long time now. I think since 2021. And then we haven't made much progress for my team per se, and then that's something that I think is more important moving forward as we see more use cases that raise up. Yeah, but if you have anything else that you want me and my team to look at, yeah, feel free to DM me. So, yeah, that's all I have. Thank you for watching my talk. Yeah, have a good day.
Hey everyone, congratulations. We are at, I'm gonna fix that real quick. There we go. We are at the most exciting topic of the day, points. I am an avid proponent for points. My name is Zane. I give out points. I believe that by the end of this presentation, you too will feel similarly to me. If you're a point skeptic, keep an open mind. We can have some Q&A at the end. Let's dive in. All right, so today I will give a rundown of what exactly points are. I will contextualize points in the history of crypto microwork. I will talk about why points are an awesome innovation in the space today, address some of the common critiques, things we can do to improve the future of points, and most importantly, give me your attention until the end of this presentation, and perhaps you too, audience, can earn some points yourself. So, a bit about me. My name is Zane Huffman. I go by Green Jeff online. That's my milady. I have been doing stuff in this space, doing tasks and getting points, getting tokens for a long time. This is me referring people to a Bitcoin Minecraft casino in 2013. And today I also give out points. I'm the CEO at Deimos, which offers orb-free human authentication. And I contribute to Block, where we have some exciting upcoming projects. All of these which have points. So, at a high level, points are a mechanic that businesses can award users, award their consumers for doing some type of engagement. Effectively, you do an activity, you get a unit of engagement. These activities can be attention-based. Come to my talk, download my app, fill out this survey, or capital-based. Deposit TVL into my protocol, trade on my exchange, use my credit card. Points are one specific implementation of microwork, so lightweight worker engagements. And what's important to note is points are not a phenomenon that only exists in crypto. We have points in the real world. People love them. We have free Starbucks drinks, airline miles, all kinds of ways to earn points all throughout the world. And they're fun. People like to earn points. Projects benefit from giving out points. I believe they are cool and good. In order to explain why I think points are so important to crypto today, I think it's important to look at the history of microwork in the crypto space. Back in the good old days, 2012, you could put these signatures on your Bitcoin Talk profile, and you would get paid Bitcoin every single time you did a forum post. You would do little things and get Bitcoin. This went like a bajillion X when ICOs launched, because now you could mint free tokens that maybe would go up a lot, give those out for good work done. Of course, in 2020, things went crazy. We got the Uniswap airdrop. We got a whole bunch of airdrops. I'm sure everyone here has had the joyous experience of receiving an airdrop. We invented getting free money for having done a thing. It's awesome. Even better, we also came up with a way that you could take that free money, deposit into a protocol, and get more free money. How could it get better than that? You guessed it, points. To explain why points are an important innovation with where we're at in the space today, it's important to understand why all of those previous micro work metas ultimately faltered. Initially, you were getting paid Bitcoin to do things, and then Bitcoin went up a lot. Instead of this being an effectively free-to-mine currency that you could tip and give out, it was suddenly worth something. That Minecraft casino I referenced shut down because they were giving out 2 Bitcoin every single day to Minecraft players. They decided they actually wanted to hold on to their Bitcoin. In 2016, we realized we could create new tokens, ICOs, and give people future tokens for doing micro work. If those tokens did well, they sold their ICO, they got listed on Binance, those micro workers could have made thousands and thousands of dollars for very lightweight work engagements. This, of course, was abused. People spun up botnets where they were spoofing hundreds or thousands of workers, and scammers used micro work as a way to sell their token without actually intending to pay people out. in 2020, we hit it again. We got airdrops and yield farms. We invented the free money and the free money duplicator. How could this have failed? There we go. Well, a few things happen. One, airdrops were supposed to be surprising. You participate on a protocol. Later, they drop a token, and you get incentivized for having done stuff in the past. This was quickly gamed by insiders. If you're a regular person going in blind, you might get an airdrop, but if you're an insider, you might get most of the airdrop. I'm sure we've all seen instances of this happening before. Also, people started to Sybil farm. They would create thousands of wallets and spoof the same activity over and over again. Real users were no longer getting the good airdrops. And at the same time, Bored Apes were stolen. What I mean by that is those real users pressing buttons trying to get airdrops were also being targeted by phishing attacks. It was less and less expected value to be a regular person farming for airdrops. On the yield farming side of things, the flair and the fervor died out. People were not buying the tokens as much as they did initially. The farmers deposited wherever they would get the highest APY. They sold the tokens. Those tokens ran out, and then the TVL left. At the end of the day, you had airdrops going to not real users and yield farm payments going to TVL that would leave as soon as the money ran out. Fortunately, we have a solution. It is points. Instead of issuing tokens after the fact through airdrops or during the fact through yield farms, issue points for that attention. This is a proactive way to fairly engage activity. Instead of there being surprise could be abused, you can tell users exactly what you're looking to incentivize. Users know exactly what they need to do to win incentives, and projects get exactly the type of engagement that they need. Also, TVL is much better bootstrapped with points because there is much more opportunity cost for that capital. You don't get to just deposit in whatever the highest APY is. You need to figure out what protocol you align with, you are passionate about, and believe that your exposure to that protocol will do you well. This enables a much higher affinity between users and the protocol. Generally, with both types of points, attention-based tasks and the capital-based tasks, it's a much better way to get good real users and good real capital that are interested in the longevity and the success of your protocol. Also, it's fun. I've got that's my blast screenshot up there. I roll that wheel every day. There's flashing numbers and lights. It's fun. It's fun to spin the wheel and get those points. That's the Linear Park quest down there. It's very engaging. It's very gamified. It's fun. It's awesome. I love points. And I think that it's a much better way that users can engage with projects, be iteratively incentivized for doing so, and projects can have a more fun, more cohesive engagement with their users. Unfortunately, not everyone agrees with me. Points are very controversial, as you guys may understand. I'm going to address some of the common criticisms. Number one, points are not fair. I think that is totally the opposite. Points are super fair. They are way more fair than airdrops. They are way more fair than yield farms. There we go. Another one I see. This one mostly in regards to where people are depositing and they're locking up their assets. Points are illiquid. I'm forfeiting yield to get a point that might be worth something in the future. First of all, I think it is important that you require a higher affinity to the project you're depositing in. Additionally, there are new mechanisms in the market that get around this. On Pendle, you can separate the point and the yield, and you can speculate on the underlying asset and the opportunity to earn points separately. Whale's Market also allows you to trade points over the counter before the airdrop. It is totally... you're totally able to trade points even if they're liquid. And more of that is going to continue to happen. I also see people posting on Twitter that they don't like earning points. These are people who post on Twitter to get likes and retweets. I think they are lying to themselves. I think points as a little hit of dopamine is way better than getting a like or a retweet or a follow. I will die on that hill. This one comes up a lot too. Points are not innovative. They exist in the real world. They have for a long time. We did not invent them in crypto. This is a good thing. We know the legal clarity around points. We have the market research that people like to earn points, that it's effective for projects and businesses. This is a good thing. We're not shooting in the dark. And for projects looking to stay above the belt legally, this is much safer than distributing those surprise airdrops. Lastly, this one upsets me. Points are bad because they're centralized. I've created this diagram to illustrate why this upsets me. If you're speculating on a new project that just launched or is about to launch and they don't have a token and a team needs to build the project, you are engaging in a highly centralized endeavor. And there's a lot of ways that the project can screw you over. A project can rug pull you. Even worse, a project can hide an exploit in their contract and they can rug TVL. It is bad if projects put out a points program to get engagement from users and then they decide they're not going to do an airdrop. They sunset the program and the users are not rewarded. That's bad. But in the scope of how new malicious projects can screw you over, it's not that bad. I don't think projects have more faculty to rug users if they have access to points. With that being said, points are not perfect. Here's some ways that I think we can improve the points meta, new innovations to come, so that this can continue to be an important micro work niche that does not die out like the previous versions. Number one, accountability culture. If projects are rugging users, if they're taking their points programs and axing them or sunsetting them or pretend they don't exist, do not engage with those projects. Projects, if you're offering points, do the right thing. Additionally, we still have a lot of issues around Sybil attacks and the notion that it's difficult to assert that a participant in a project is a unique person. We need to enable the ability to vet users on the blockchain as unique individuals. This enables more nuanced engagements. For example, you can offer surveys to get acclimated to a project, and you can't do a survey 1,000 times. Our project, Deimos, helps to enable this type of proof of humanity. There are others in the space that are working on this as well. I believe that we will have a much better grasp on proof of humanity going into this next cycle. Lastly, be intelligent about how you're offering points. Be intelligent about how you're issuing points. Just because a project has points doesn't mean they're automatically a good project. If someone forks Uniswap and they put points on top of it, it doesn't mean you need to give them your attention. Projects, if you're just looking for getting likes and retweets on Twitter, that's not a good use of points. Get people to use your app. Get people to understand the project and grow out the community. Lastly, this is the most important part of the presentation. Thank you for your attention. Claim this POAP and you will get points. Everyone who claims this POAP will get points for Deimos, which will potentially be good when we launch our token. Also, the projects I'm working on at Block have points programs as well and are also pre-token. Lastly, if you guys want to find me, I'm Jeff the Dunker on Twitter. That's my milady. I'm on TikTok as well if you're on that cursed app. Thank you. I have to leave this up so people can claim it, but if anyone has questions and you're able to shout, feel free. Otherwise, come talk to me down on the side. Thank you.
Awesome. All right. Hi, everyone. I'm Kaido. Today, I'm going to talk about you could have invented eigenlayer. And hello to the friends, on YouTube watching this in the future. All right. So first, I want to give a quick acronym for this talk because we're going to, going back in the future, mention this along. You could have invented eigenlayer. The acronym is YCIE, YC, YC, and the last part is we're gonna reference this talk as a YC talk. And the reason is I hope that after you understand what this eigenlayer thing actually is, it's gonna show you the endless possibility you can build on it, and this is a YC moment for you. All right, let's get started. First, what is eigenlayer? So I have two options here. A is Sriram, and B is some diagram. Just show of hand, who thinks A is eigenlayer right now? All right, we see a few hands. Awesome, thank you. All right, who knows what B is or have seen B? Oh, we have a few hands too. Awesome. So at the end of the talk, hopefully you will understand, eigenlayers both, right? Sriram is our great founder, and B is our architectural design. So the goal of today's talk, we're going to cover 4 different points. First, we're going to start from first principle and think about what problem does eigenlayer even want to address. Second, we're going to think about, okay, to address these problems, what are the requirements to solve individual problem? The third thing is going to be, okay, let's build this protocol out to address these requirements. And lastly, let's make it into a product. What's the problem statement? The problem statement is the following. Bootstrapping any decentralized infrastructure is difficult. Crypto aims to remove intermediaries, and when not possible, we try to increase the security and resiliency. So how do we increase the network security and resiliency? Normally, we use a decentralized network. But building a decentralized network is hard. But why is that? Most decentralized network requires consensus. A consensus mechanism are difficult. We have a few different flavors of consensus mechanism. Proof of authority, some people may call it multi-sig, meaning just a few authorized people can make changes onto the network. Another one is proof of stake, pioneered by Satoshi with Bitcoin. And lastly, that's gained a lot more popularity recently is proof of stake or POS systems. To bootstrap any proof of stake system, the stake in proof of stake is really, really hard. And there's a few reasons for that. So first, what is a stake in a proof of stake network? The goal for stake inside a proof of stake network is to do simple resistance so we know who are the individual nodes to the network, and they generally represent some economic value. The first reason why it's difficult, I'm going to run through this really quick, and I'm going to go back to it to explain in depth why each one of these are difficult. The first one is the stakers and the developers, it's very hard to find one another. The second reason is in order for you to contribute to any proof of stake networks today, you must be exposed to the extreme volatility of these individual network tokens. The third thing is if I contribute my economic stake to your specific proof of stake network, there's no way I can expose to other yields with from other proof of stake networks. And the effect of that is if you're a new proof of stake network, you must compensate this opportunity cost coming from the staker side. And lastly is, under this design of each individual network having different proof of stakes, they are going to have a fragmentation of security problem. All right, what does each of these mean? The first one is, it's difficult to identify where stakers are from a developer point of view. And the reason, then the sort of symptom of this is most proof of stake networks, their economic security is closely tied to its fundraising, meaning most economic security for most new protocols will be provided by its investors. Is there any way for us to connect the stakers with the developers other than through this fundraising mechanism? The second and third are very much directly tied together. For me to contribute to a new proof of stake network security, I must acquire the token for that specific proof of stake network, and then I have to stake it, and the network will give me rewards in return. Because I'm buying this token, I'm exposed to a lot of price volatility of the token. The network needs to compensate me a lot, generally, in the double-digit APRs. And this sort of goes into this potential scenario. Imagining a proof-of-stake network, your token price drops a little bit, you have weakened security, your TVL decrease as a result, or your activity decrease as a result because people don't trust you as much. And because your TVL decrease, your token price drops even more. And then you have a very vicious feedback loop where less economic security means less economic activity, less economic security, and vice versa. The last part is in the current proof-of-stake bootstrapping model, security are fragmented. You may have seen this graph from Shiran before. This is one of the problems. Imagine you are building a decentralized application, and you're relying on 3 different other proof-of-stake networks. One of them is a bridge, one of them is an oracle, and one of them is a co-processor. Each one of them have about $1 billion in economic security. But your application is built on Ethereum. I should probably add a 0 here, because yesterday, Ethereum surpassed 100 billion economic security. In this model, to compromise this decentralized application, even though it's built on Ethereum with 100 billion economic security, it is actually the weakest link of the two, of the 4, which is $1 billion. Imagine another world where instead of fragmenting the security, we pull the security into the base layer of Ethereum. So Ethereum has 13 billion economic security. It goes through EigenLayer, and EigenLayer bootstrap these individual proof-of-stake networks. Now, from a decentralized application developer standpoint, to use each one of these bridges, oracle, co-processors, I am under the same security assumption as building on top of Ethereum. So those are the problems. How do we find solutions, or what are the requirements to solve them? Just go over one more time. It's hard to connect stakers with developers. It is hard to acquire the token, and we don't want to always, tie a specific network with a specific token. We want to compensate users on their opportunity costs or lower the opportunity costs. And lastly, we don't want to fragment security. Instead, we want to pull security. So given those individual pain points, what do we need to do? First, we need a platform to connect stakers and developers. What does that platform mean? I'm going to talk about it in a bit. The second part is stakers should be able to provide economic security using any token, not just like the specific network token. Stakers should have the ability to restake and to contribute to the security of other infrastructures while earning native ETH yield. Therefore, when you're bootstrapping a new proof-of-stake network, your stakers' opportunity costs are much lower. And lastly, through this mechanism of restaking, EigenLayer pools security instead of fragmenting it. All right, those are a lot of words. Let's try to build our MVP. And we have 10 more minutes to finish building from an MVP to the end stage of what EigenLayer is. So first, what is a platform between stakers and infrastructure builders? Here, I illustrate a very high-level idea of what a proof-of-stake network is. So you have a few participants. You have the staker, you have the protocol itself, and you have the end user who are consuming services from the proof-of-stake network. And then lastly, you have the developers who are writing the code that runs the protocol. An example would be an oracle. The oracle developers would write the oracle protocol. The stakers would contribute stake to the oracle for its economic security. And lastly, the oracle protocol promises its end user that its price feed will be accurate and would not be maliciously manipulated easily. Normally, these users are just smart contracts. The other side of the promise is if such promise, the oracle promise made to the end user is broken, then the staker who contributed to the economic security of the underlying network will be slashed. Developers design these commitments. Stakers make these commitments by staking. And then lastly, the protocol enforces the slashing of these individual tokens. So actually, if you abstract far enough, all we need to do to build this platform, we just need to satisfy 2 requirements. The first requirement is the ability to make commitment. And guess what? Ethereum is the best commitment making device. The second part is enforcing some commitment, sort of similar to running some function. And the best place to do it is Ethereum. You can make a commitment through smart contracts, and enforcing a commitment through a function call. This is the simplest MVP we will start with. A staker deposits some of its token into a token pool. And inside the token pool, there are some commitment logics. What would it look like in practice? It will look like something like this. If you don't understand Solidity, don't worry about it. It's very, very easy to follow. The first mapping basically tracks how many people have how many tokens. You have the stake function to get into the pool. You have the withdrawal function to exit the pool. And lastly, you have a slash function, meaning if you misbehave as a staker, you should be slashed. And as you can see, there's some question mark here, meaning whenever you will be slashed, somebody needs to submit a fraud proof or evidence that you've committed things that deviate from the underlying commitment. In the Oracle example, that means you've reported a price feed that significantly deviates from the actual price feed. So we cross out the first requirement we need, which is creating a platform to connect stakers with infrastructure builders. The next part is contributing economic security using any token. That one is easy since we're building on Ethereum and we have infinite amount of ERC20 tokens. The third part is a little bit tricky, but here we're going to take a shortcut. We're going to say, hey, there's a lot of liquid staking tokens out there. If we can take them in as economic security of the underlying proof of stake network, then the stakers of those new proof of stake networks do not need to forego their ETH rewards. So that part is crossed out. We have another mechanism that go through the bypass the liquid staking tokens, and that's called native restaking. It's on our docs page. If you want to learn more about it, take a read. Last part is through restaking, EigenLayer pools security and start fragmenting it. So what does it mean here? So in the previous example we just described is some staker deposits some token into the token pool. But if I want to make another commitment, then I need to deposit another token into another token pool, right? So each one of these token pool are sort of each one of the commitment to a single specific proof of stake network. So how do we do that? We achieve that by compartmentalizing the slashing function. What does it mean? So now as a staker, I can deposit my token into the token pool. The token pool doesn't have any slashing logic ties to it. However, what the user could do is enroll into let different slashers to slash its stake. So slasher 1 could hold the logic for an oracle, slasher 2 could hold the slashing logic for a bridge, slasher 3 could hold the logic for slashing for a coprocessor. And the possibility are basically endless here for you to design your specific slashing condition. I'm not going to go through the exact contract, sort of a high-level idea, but feel free to take a pause here or take a picture. And with that design, we actually cross out all the requirements we need to satisfy the initial problems we came to solve. We establish a platform. Stakers can contribute economic security using any token. Stakers have the ability to restake and not forego their ETH rewards. Lastly, through restaking, EigenLayer pool security and start fragmenting it. And this is the MVP of EigenLayer. It achieves most of the things we came here to achieve. And the rest of the talk will be very, very fast since I only have 20 minutes. I'm going to run through a lot of slides. So if you're online, feel free to take a pause and read through the smart contracts. But in the rest of the talk, what I'm going to focus on is we're going to try to bring this MVP, minimum viable protocol, into a product where end users and developers, and also a new concept we're going to call operators, will be able to participate. The first thing we identify is staker doesn't always want to operate its own thing, right? That's why a lot of staking companies exist, why Coinbase exists. So we're going to add an operator role into the EigenLayer contract, but it's a little bit messy. So we're going to compartmentalize and modularize the, sorry, if you're taking picture, that might be a little bit too fast. So we basically are tracking a lot of different variables to understand what is the relationship between the stakers and the operators. And the operators are basically the people who are running the underlying infrastructures to secure these different proof of stake networks. So instead of having that big wall of code, the design will simplify to something like this, where we have the delegation manager, which is at the bottom of the screen. And what the delegation manager basically does is it tracks the relationship between a staker and an operator. For example, Kaido used to stake to secure an Oracle protocol. But now Kaido is like, no, I don't want to secure it myself. I'm going to delegate that responsibility to Coinbase. And Coinbase will be able to run that delegation on behalf of me. This is very similar to delegated proof of stake mechanisms. The second thing we're going to do is this design only supports one token at a time. But that is very simple to solve because before we're going to have one mapping to track one specific token. So what we're going to do is have something very similar to the Uniswap design where you have a token manager and the token manager handles tracking of how much user owns inside different token pool. And you can think of each token pool are different holding different token. So this one could be staked ETH, this one could be CB ETH, etc. I'm going to pass through the contract code here. I'm going to take a quick 3-second pause for pictures. Awesome. And this I'm going to spend a little bit more time on, which is expanding the ABS design. I think some sharp audience would already identify some of the problem that exists in the current design, which is the following scenario. Imagine I'm a staker and I'm also running my own operator. I commit some malicious behavior on the first timestamp, highlighted here. And then in the next time instant, I'm going to instantly withdraw from EigenLayer. So now my funds are completely off EigenLayer. I cannot be slashed anymore. By the time somebody relays a fraud proof, for example, submitting the evidence to the EigenLayer protocol to state that somebody, I have done something malicious, it's too late. I am already outside the protocol. So what we need here is when we commit a malicious activity, we cannot withdraw until someone submits a fraud proof. And this is very similar to the 7-day optimistic fraud proof window or the unbonding period for some proof of stake networks. We're not going to change anything here on the design. This is the current design we land on. Instead, we're just going to add a simple variable called unbonding period. And what unbonding period will do is if I want to withdraw from EigenLayer, then I need to wait for a specific time frame to give people to submit the specific fraud proof. I'm not going to talk about this here, but this slide gives the idea that now withdrawal is no longer, I call one function, I get my money back. Instead, I need to queue on withdrawal, and I will complete my withdrawal after the unbonding period finishes. The last part is a gas optimization issue. So in the current design, what we sort of run into is there's a lot of different slashers, and we need to check with the slashers on the status of different individual operators. And these cross-contract calls really add a lot of gas burden on the end staker, especially when small stakers, when they try to stake and withdraw, if the gas cost is really high, it may never be economically viable for them to participate in the system. And the way we achieve it is by having a slasher manager. Similar to the previous idea, slasher manager tracks the relationship between each single operator and the individual slashing condition the operator is enrolled in. And that's it. This is the design of EigenLayer on a very, very high level. There's some parts of naming convention is different for simplicity and understanding, but this is sort of what, on a high level, what EigenLayer is and what restaking is. Feel free to take a picture because this one, I think, is going to be one of the most important slides here in the deck. All right. Lastly, this talk is titled Why You Could Have Invented EigenLayer. If you want to reference this talk, call it the YC paper or the YC talk. And that's the end of my talk. Thank you guys so much for your time.
Looks like I'm just gonna swap the displays. There we go. Okay. All right, this talk is titled Sharing a Sequencer is Caring About Interoperability. I am Ben Fish. I am the CEO and co-founder of Espresso Systems. I am also an assistant professor of computer science at Yale. So, rollups are horizontally scaling Ethereum. Rollups are this beautiful solution that allows for sharding of computation across different applications. It allows for powerful servers to also help much weaker nodes verify what the state is, which allows for greater decentralization of Ethereum while supporting many, many more applications. It also enables virtual machine diversity. So you can add new applications that are not even running the EVM, and they can just simply prove their state transitions to the layer 1. So rollups are this wonderful innovation over the last few years that have brought tremendous benefits to the Ethereum ecosystem, scalability and virtual machine diversity in particular. But one of the things that rollups do today is they run what are called isolated sequencers. And this has a significant drawback. The drawback is that interoperability between applications across different rollups is very limited. Okay? Bridging is slow and costly, and this leads to a loss of what we call synchronous composability between applications and liquidity fragmentation. And the value of Ethereum is really in its unity, right? Not fragmentation. Seamless interoperability of applications is the promise of trust-minimized infrastructure and what really differentiates Web 3 from Web 2. So let's take a little look at what the job of the rollup sequencer is and why rollups are running isolated sequencers today that hampers interoperability. So the job of the sequencer is to collect transactions from users and periodically summarize the result of executing those transactions and post it to the Ethereum network. This, in a ZK rollup, would also come with an immediate validity proof, which allows the Ethereum network to verify that the state update is correct. So it determines rollup blocks and which transactions are included in those rollup blocks and their ordering. A sequencer may also run an auction. So it naturally gives rise to an auction where builders are bidding to propose the next block, and the sequencer kind of runs an auction among these builders, and that helps it produce the most valuable block it can, which is the same dynamic that happens with leaders or proposers in Ethereum's consensus protocol. Now, based sequencing, which is the most recent, let me just, based sequencing, which is really the original version of rollups, is as follows. So L2 nodes just read the finalized transaction list from the L1. There's no sequencer, there's no additional sequencer. They just read, the users send their transactions directly to the rollup smart contract, And L2 nodes read the finalized transaction list from the L1, they execute them, and then periodically post what the state transition is, along with perhaps a ZK proof to the layer 1. So by using the layer 1 itself as the sequencer, the advantage is, one, it inherits the decentralization and liveness and censorship resistance of the layer 1. You're not introducing this external party. And number two, because all these rollups are then sharing the same sequencer in effect, it results in improved interoperability, not only between rollups, but also between rollups and layer 1 applications. And I'll get into in a little bit more detail why that is the case. But before, why is this important? Well, ultimately, users just want a secure, convenient, and low-cost experience, right? They don't want to think about necessarily being on one rollup versus another. Satisfying user intents will be most efficient across applications that are deployed to rollups with the greatest unity, and not only with each other, but also with smart contracts on the Ethereum L1. So that's why this is so important. Now, so what is enabled by having a common sequencer between not only rollups but also the layer 1? What is the benefit of this? Well, the way the layer 1 works is that it always has a proposer that's building the next block, right? It has proposers, and then it has validators, which are attesting and signing on the block proposal and making sure that the network has received it and doesn't forget it. So this elected proposer from the L1, if it's also producing blocks for rollups, then what it can do is it can promise to users things that it will do synchronously between different rollups and maybe even the L1 itself. So here's a simple example. A rollup user wants to take advantage of some arbitrage between two AMMs on different rollups. So it says, I want my two transactions on rollups A and B to execute atomically. Now, the L1 proposer can give this promise to the user that it will execute its transactions on both rollup A and rollup B, or otherwise not included in the L1 block. Now, this doesn't give the user the same exact protection it has when just atomically taking advantage between arbitrage of two AMMs that are on the Ethereum L1 itself, or on the same rollup VM itself, but it's still quite powerful because the promise that the L1 proposer gives is slashable. Right? Violating a promise is a slashable offense, and even the user could collect damages. So promises function almost like an insurance policy. And importantly, the honest proposer can make these promises without any risk, so it can offer very low-cost insurance. There's much higher risk without a shared proposer. You can imagine that a builder would try to make the same promise to a user interacting with two different siloed rollup sequencers, but rollup A sequencer or proposer might accept its transaction while the rollup B proposer rejects it. So there's no real way for this external builder to make this promise unless there is a coordination. So proposer promises, or what are also known as pre-confirmations, they enable a shared proposer for a bundle of multiple rollups to do many things, including acting as a liquidity provider, making promises to satisfy arbitrary user intents, atomic execution of several transactions across different rollups. They can also provide very fast confirmations of what it has proposed, even with 100 milliseconds latency or less, even though it takes much longer for Ethereum to finalize what happened. There is some risk that this pre-confirmation will eventually be reversed, but again, it can act as like an insurance policy that the proposer gives to a user, which can be checked in very, very short time. It can also be used a shared proposer can also be used to coordinate message passing between ZK provable chains. So this is something that Polygon AgLayer describes. And with improvements in the latency of proving, which may ultimately enable us to do real-time proving, even 100 millisecond latency proving, then this could ultimately enable synchronous interactions between L1 and L2 contracts. So again, violating a promise is a slashable offense, and if users can collect damages for violations of these promises, then pre-confirmations act as a form of insurance. There's many examples of cross-domain user intents that we might want to use pre-confirmations to satisfy. Some examples are capturing arbitrage, as I already gave an example of. Maybe finding the cheapest way to execute an asset swap, and that may involve multiple DeFi exchanges or liquidity providers across multiple chains. Or buying an NFT on one chain with funds from another, but not wanting to first bridge and swap assets unless you know that the purchase will actually succeed in the end. So this sounds all great, but what is base sequencing missing, right? Why were external sequencers introduced in the first place? Well, number one, better data compression, which ultimately translates to lower data availability costs. So an external sequencer collects transactions over time and can optimize when it posts them to the Ethereum L1. And also fast, what I'll emphasize is low-risk pre-confirmations. Okay, what we just talked about before with L1 proposers giving promises over what might happen, there's always the risk that even if they do nothing wrong, their promise will be violated. Because Ethereum could experience a reorg, and transactions that they included could be dropped before 15 minutes have elapsed. Okay, ultimately, higher risk means that if they're going to give insurance to users, it's going to be higher cost. An external sequencer can pre-confirm pure L2 transactions that do not depend on any unfinalized L1 transactions with virtually no risk at all of being wrong because they have complete autonomy of what they're going to do with the roll-up contract. Right? They have an exclusive right to update the L2 state. So better data compression and fast, low-risk pre-confirmations were the real reason why external sequencers were introduced in the first place. The original Arbitrum paper actually had no external sequencer. These were introduced later. Now, is there a middle ground? Yes. Base sequencing can have its cake and eat it too, in some sense too. What we can do is we can introduce an external finality gadget. Yeah, we call this a fast finality gadget, and we could have L1 validators even opt in to participate, say using eigenlayer restaking, as Kaida was just talking about in the last talk. So what does this do? Well, the rollup smart contract on the L1 will require, transactions to be first approved by the fast finality gadget. So users are sending their transactions still to an L1 proposer. The L1 proposer produces a super block for all these rollups, but it needs to get it approved by the fast finality gadget first, right? And then it will be settled on the L1. And so the rollup smart contract requires this fast finality gadget, which could be a BFT consensus protocol operated by an opt-in set of validators to approve all transactions. And this still maintains L1 composability because the L1 proposer is still proposing. It's still building the L1 and L2 blocks together, but it first needs notarization from this fast finality gadget. What we can achieve here is something what we call conditional finality. The finality of any L2 transaction is now conditioned on the finality of the most recent L1 block that it depends on, and of course the security of the fast finality gadget. So this inherits the benefits, the composability of base sequencing, but retains also the benefits of external sequencers that were introduced by rollups. Now, what else is base sequencing missing? Especially now that we're used to rollup sequencers. Well, MEV capture for rollups. So enshrined rollup sequencers have additional revenue beyond the gas fees in rollups, which come from tips that users are paying for satisfaction of intents, whether they're pre-confirmation tips, which generalize order priority fees or standard order priority fees. So vanilla base sequencing is simply not economically aligned with rollups. And so a solution is to have a mechanism to redistribute sequencing MEV that flows to the Ethereum L1 or whatever is doing this shared sequencing back to rollups. So we can view shared sequencing as an auction. It gives rise to this auction where proposers are bidding on rollup block bundles. We can auction off the right to update all rollups or a subset of rollups at once to bidders. Proposers are competing with each other and bidding on the right to produce this super block. Okay? So the difference between shared sequencing and isolated sequencing is the difference between a shared auction versus isolated auctions. Right? In the picture today, every roll-up sequencer essentially auctions off the write on its own to produce the next block on that roll-up. Whereas with something like shared sequencing or base sequencing, we have a joint auction where the roll-up block spaces are auctioned off all together, and someone can bid on the write to produce a bundle of all roll-ups together. Now, the shared auction revenue may be higher than the combined isolated auctions, but how should we share the auction revenue with individual roll-ups? Is there a stable mechanism through which roll-ups can dynamically participate in this mechanism such that they're always convinced they're better off running in the joint auction than in isolation? There's many analogies to this. We can look at bands playing at a music festival, right? The festival sells tickets. How is the ticket revenue allocated among the bands? Travel agencies sell tickets combining flight legs from multiple airlines. How should the ticket revenue be allocated among airlines? A toy example is, let's say you have two companies, one that manufactures left shoes, one that manufactures right shoes. It's obviously better to sell the shoes as a pair in a store, but then how would you split the revenue between the two different companies so that they're convinced they wouldn't be better off selling left shoes and right shoes on their own? So a solution is what's called a combinatorial auction, where proposers can bid on any combination of roll-up bundles that they want to produce, and each bid is for the right to propose this bundle of blocks in a specific slot. Now, for each slot, we would select a partition of roll-ups into bundles that maximizes auction revenue, and this can result in even multiple proposers. Right? It wouldn't necessarily be one proposer for all roll-ups all the time, and every roll-up receives at least its highest bid. In fact, every roll-up can even bid on itself, which functions as what's called a reserve price. A reserve price is the minimum price at which a seller is willing to sell a product. So if a roll-up bids high on itself, then it can ensure that it will at least make as much as it would make running on its own in isolation. If it bids too high, it will be excluded from bundles that are assigned to shared proposers. Now, burning part of this bid can also further disincentivize what's called shill bidding, where they're bidding too high, and that's reducing the efficiency of the overall allocation. And this is similar to what's called a harbinger tax. So, but wait, how is this base sequencing? Right, I said that base sequencing gives the right to the L1 proposer to produce the next block, not only for the L1, but for all rollups. So where does this auction come in, right? What the hell is this auction? What about the L1 proposer? Well, this can also be a version of base sequencing. Okay, so this is what I call base sequencing 3.0. So after running the combinatorial auction, which anyone can participate in, the L1 proposer for the Ethereum L1 block in the same slot can be given the option to purchase the proposal rights for any bundle it wants at the winning bid price, plus perhaps a premium because it can produce even more value since it's also producing the L1 block together. This price at which it pays for the bundle will always exceed the sum of reserve prices for rollups within that bundle by design. So what is shared-based sequencing, after all, in light of this picture here? Well, it is a marketplace. It is a marketplace through which rollups can sell block space to shared proposers who create surplus value by satisfying user intents across multiple chains. And for base rollups, that includes the Ethereum L1 chain itself. So thank you. We are Espresso Systems. We are building a shared sequencer and a shared sequencer that also supports base rollups too. So please follow us on Twitter. We are at Espresso Sys. My Twitter handle is at benefish. And stay tuned for updates. We have a new testnet coming out soon called Cappuccino.
ready to go? Yep. Hey, so I'll give a presentation about risk management and decentralized finance. This may be a topic that's a bit less sexy than what we had on the stage earlier today. But I feel that it's very important for both people allocating capital in DeFi, but also people building protocols and building liquidity pools to kind of get the point of view on the asset manager side and on the liquidity provider side. So what this presentation will be about is to kind of give an overview of how sophisticated LPs and sophisticated asset allocators look at the risk in DeFi. So brief background on myself and Dialectic. So Dialectic is a Swiss asset manager. We execute three main strategies. So we have an early stage venture capital fund that invests in DeFi and infrastructure and gaming and all sorts of companies in that space. And more importantly for this presentation, we do run two DeFi yielding vehicles, one being stablecoin denominated and the other one being ETH denominated. So we have been doing this for 3 years now, basically since DeFi summer started. And so we had a lot of time to refine the risk frameworks and to refine the way that we look at risk and that we measure risk and the way that we allocate liquidity across DeFi. I myself am the CTO and I'm portfolio advisor on the ETH-denominated yielding book. So I've built out a bunch of the software that we use to manage the risk, as well as provided some input to the investment team around the risk management framework and how we look at that. We also work quite closely with protocols and ecosystems to provide specific liquidity to key pairs. So many of the big ecosystems that are launching now, they require liquidity on stablecoin pairs or different ETH pairs. And they found it rather efficient to work with professional parties like us to provide liquidity in very specific pools on specific conditions. So why do we care about risk? I mean, most of you are aware that DeFi is a rather adversarial environment. Some people call it a large financialized PvP game. Because on the one side, we have the users who hold their assets and who want to get some yield on their assets, so they deploy it into liquidity pools. But then on the other side, we have a set of users that is highly adversarial and that is actively trying to exploit the protocols and steal the liquidity and basically wreak havoc in DeFi. And we even have like state-level actors such as Lazarus Group from North Korea, who was responsible for some of the largest hacks that we had in the space. And so it's very important to understand that anyone can access DeFi, anyone can play with DeFi, and anyone can try to exploit the different protocols and steal the liquidity. And this is why for someone like us who has like large amounts of capital deployed across DeFi, having a very strict and coherent risk framework is the only way that you can really do yield farming at a large scale. So the meat of the presentation will be around the risk framework and all of the different categories of risk. And then I'll also have a couple of slides about risk mitigation that will kind of go through some ways to do this in a sustainable and safe way. So the way that we look at risk is that we break it down into 5 main categories. So we have the chain risks, which are all of the risks associated with the infrastructure layer. So this would be like the economic security in a proof of stake network. It could be things around like centralization of key nodes and things like sequencers. And here we mainly care about the consensus as well as the liveness. Because even like liveness, if a chain is down for a prolonged period of time, that may cause some problems for oracles and lending markets that don't have up-to-date price feeds. So that's everything that has to do with the infrastructure layer and the chain layer. After that, we need to look at the bridge risk. So anytime we are deploying assets that are not on the Ethereum mainnet, we need to bridge those assets to the chain that we are deploying on. And so we do have some exposure to the bridge that is issuing those assets. And if the bridge were to get hacked or drained, the bridged assets would depeg, their value would go to 0, and we would have a loss on that. Then going down the stack, we reach the smart contract risk level. This is actually probably the biggest risk in DeFi. Like historically speaking, if you look at the assets lost in DeFi due to exploits, a big part of that was smart contract exploits. And it's a very difficult thing to manage because smart contract systems can get quite complex. And as we'll see in a bit, there's a lot of dependencies and things to consider. So yeah, smart contract risk is a big one and a rather difficult one to assess and mitigate. But then even if the smart contracts are fully written correctly and it's all safe and sound, most of the protocol have some economic mechanisms that could get compromised. So in the case of lending markets, for example, we need to look at the collateral type, we need to look at the LTV, what the liquidation procedures are, and all things related to that. Then many protocols rely on oracles, so they need some external price feed to price the assets, and oracles can be manipulated. So all of those types of risks we bucket in the economic risk category. And then lastly, we have governance risk. Now this is important because most protocols are upgradable. And so when we do a due diligence on a protocol or an asset, we are basically looking at a snapshot in time. And if the protocol is upgradable, it could be upgraded, and that could introduce some vulnerabilities or some extra risks that the users are exposed to. So we need to analyze who can update the protocol, how the protocol can be upgraded, what's the time lock situation, and all things like that. So once we define the 5 risk categories, we need to understand that DeFi is highly composable. And when we look at a specific pool, so the example here is this dollar for XPP pool, which is a curve pool, and curve LP token is staked in Convex. We don't just have exposure to a single protocol, but we actually have exposure to a bunch of underlying dependencies as well. And what we're trying to do, so the end goal here, is to basically get to a risk score for each one of the pools in DeFi that is coherent and that allows us to compare the risk of different pools. So in this specific example, we would have a chain risk on the Ethereum chain, which is basically very low. We don't have any bridge risk because all of the assets are native to Ethereum, so we're not exposed to any bridges. But then on the smart contract, economic, and governance side, we do have exposure on multiple levels to multiple protocols. So we have exposure to Convex, Curve, and then Dollar. The stablecoin is issued by Inverse Finance, which is its own protocol, which it's with its own set of smart contract, economic assumption, governance model, and so on. And the same for XPP. So this is kind of one way to visualize it. And the way that we then get to a quantitative risk score for any specific pool is by basically compounding the risk of all of the dependencies. And for each one of the dependencies, we compound the risk of the individual categories. So in the previous slide here, we would have like a risk score for Convex, which is made up of the chain risk of Convex, the bridge risk of Convex, smart contract, economic, and governance risks. And so basically, if we know the risk score for the underlying dependencies, we can compute a risk score for the pool as a whole. And the above formula here assumes that all of the risks are weighted equally, which is not really the case. Usually something like a chain risk would be much lower weighted than smart contract risk, because as I said, it's much more common for funds to be lost in DeFi because of smart contract exploits rather than a chain going down or some issues with the chain. So basically a way that we can represent DeFi pools is with a dependency graph. So here on the left, we have the example of the dollar for XPP pool from before. And we see that there is a node, which is the pool. And then this pool lives on a chain that is Ethereum. The pool belongs to a protocol that is Convex. Convex operates on Curve. And then the assets in the pool are XPP, which is basically just USDC and Frax. And USDC is issued by Circle, and Frax is issued by Frax, and so on. So we can see that it gets a bit more complex than what you would think at first glance. And then here on the right, we have an even more extreme example. Whoop. And let me just close this. Okay, so here on the right we have a more extreme example, which would be the EUSD HYUSD pool on Curve. So this LP token is staked on StakeDAO. So again, we have exposure to Curve, we have exposure to StakeDAO, but then EUSD and HYUSD are both tokens issued by Reserve Protocol. And HYUSD is actually collateralized by a bunch of yield-bearing stablecoins. So HYUSD is collateralized by Morpho USDT, so we have exposure to Morpho. It also contains some exposure to Flux Finance through FUSD. It has exposure to SDAI, so Maker. And as you can see, if any one of the underlying dependencies would be compromised, then that would have a chain reaction that causes the HYUSD token to depeg, which would cause the Curve pool to get unbalanced, and that could ultimately result in a loss on the final position in StakeDAO. So I think this is a very nice and elegant way to represent DeFi composability. And it makes it very clear and intuitive what all of the dependencies are. And it's just very cool to see like DeFi pools represented this way. Okay, so now that we rather should have a good understanding about the different risk categories and how they compound and all of the dependencies that matter, we can start to look a bit about how to mitigate the risks. And so rather obviously the first big step that you have to do is to do a full due diligence on everything that you have exposure to. So in this chart down here, we would need to do a full due diligence on each one of the underlying protocols, the underlying assets, to get to that risk score that I showed before. And so the way that this due diligence also needs to be done is that it needs to be very coherent, because if we apply different methodologies to score the risk on the different pools, and we have human bias and things like that, then we can't actually use the risk score to compare the different pools one to the other. So the due diligence needs to be very coherent and very deep and analyze all of the things that are relevant. But then even when we did the due diligence and we know roughly what the risk exposure of a specific pool is, we need to keep monitoring it in real time, because as I mentioned before, most protocols are upgradable. And so if someone does an upgrade to a protocol, that may drastically change the risk profile of this. And a small point of on this is that when a protocol gets updated, we need to do a full reassessment of the risk on the protocol. So if there is no time lock and the update just gets shipped to the live smart contracts, then we are usually forced to withdraw liquidity from the pool, do a full due diligence on the changes, and then redeploy if it's safe. This is usually a problem for the protocols that we work with and that we provide liquidity to, because when you are doing a big protocol upgrade, then it's usually because you're shipping a new feature, new protocol version. So a bunch of liquidity leaving the protocol after you do a update is usually not ideal. So here, for the people building protocols, please use time locks. Please use time locks that are more than a couple of minutes. And be very open and transparent about upgrading the smart contract so that all of the LPs have enough time to assess the changes and get comfortable with them and don't have to react quickly and withdraw liquidity. So then, once we did due diligence and we have our monitoring up to date, we can do some diversification. Because ultimately, diversification is the best way to manage risk. That's how risk is managed in TradFi most of the time. And we can actually use a lot of the TradFi methodologies and portfolio construction methods to build well-diversified portfolios. And to actually properly diversify a portfolio, as said, we need to have sound risk scores. So we need to understand what the risk is on all of the different opportunities. And these risk scores need to be coherent and comparable one to the other. But we also need to understand what the correlations are between the different risks. So if we deploy into 50 different pools on Convex, on the surface it may look diversified because we are in 50 different pools. But then if they all depend on the same smart contracts, if they all rely on Curve, then it's not actually diversified. And so once you have like a full risk overview of all of the opportunities and you have a return overview of all of the opportunities, you can use things like efficient frontiers to build optimal risk-adjusted portfolios. So you can say, this is the level of risk that I'm willing to take. What's the optimal portfolio that gives me the highest return given that amount of risk? And to properly diversify, you need to basically see as many pools as possible. So we build a bunch of software that tracks a lot of DeFi pools. So we have close to 15,000 pools that we're tracking. And those are spread across 1,400 different protocols in DeFi. That's all EVM chains. And so we can have a very broad overview of all of the pools that exist in DeFi, and we can score the risk for all of these pools with the methodology explained before. And then with such a big universe of opportunities, you can actually do some very good diversification. So you can really go broad and allocate funds in a very broad way, so that if any one of the specific protocols has an issue, it shouldn't cause a sizable loss at a portfolio level. And then the last thing that you can do to kind of mitigate risk is more of the real-time automation. So we use smart contract wallets. Most of the funds are deployed through smart contract wallets. And what this allows us to do is to basically react in real time to any changing conditions. So if, for example, a stablecoin was about to depeg and we see that there is some threshold that gets passed, we can automatically withdraw the liquidity and like avoid getting rugged on some stablecoin depegging or something like that. And this also goes for smart contract exploits. There's different providers in the space that have real-time alerting on smart contract exploits, so you can also integrate that. And then you can just get out of the position, get your funds back to safety if something catastrophic is going on. So the conclusion here is for the LPs and for the people allocating capital in DeFi, it is a highly lucrative business. I mean, especially right now that the yields are coming back and the returns are very high, there is a lot of good returns to be made by allocating funds to DeFi, with the caveat that the risks needs to be managed. Because if you're getting 50% APR on a farm, but then you get drugged, you're still probably down a bunch. And for the people building protocols, as liquidity is getting more scarce and as the competition for liquidity increases, it's very important to understand how the LPs perceive your protocol from a risk perspective. Because it's usually not enough to just throw a bunch of incentives and liquidity rewards onto the pools. Because if the LPs think that the risk that they're taking by deploying capital in the pool is higher than what you're paying them, then you won't get any liquidity. So understanding a bit how the LPs look at the protocols and how risk is assessed, I think is very important, especially moving forward into an environment where liquidity is more scarce and more competitive. So thanks so much for listening. This was it from my side. I'll be down there if anyone has questions.
Thank you. Hey guys, I'm Vlad from Lighter, and we're here at ETH Denver to announce ZK Lighter, which is a new approach we have to Ethereum native order book exchanges with a novel zero knowledge construction. So I'm excited to talk you through kind of why this problem is important, how we went about solving it, some of the architectural decisions, what some of the applications are, and talk about the work ahead and open it up in case folks have questions. So just kind of for some background, right? Let me kind of start high level. So what types of exchanges are there? The most common type of exchange across finance is what's called an order book, right? So in an order book, there's competition between all participants, retail, market makers, high frequency traders, and others. Kind of anybody could submit or bid on an offer. Anyone could take that bid or offer. It's the most efficient price discovery mechanism. But this type of exchange works best when you have low costs and low latency. So in practice, in the crypto world, like most of the applications of order books have been centralized kind of until some of the technology that we're going to talk about today. But the order book model is kind of, from a finance perspective, from a market efficiency perspective, is the most efficient way to design an exchange. Some other approaches are an RFQ, where basically market makers compete to fill orders from retail. This one has some good properties, but there's less incentives for efficient price discovery because the market makers aren't trading with each other. They're just, as long as they win that one order, that's all they're trying to do. So it's a lot less efficient than a system where anybody could trade with anybody. And of course, the most common one in our space has been an AMM, which is much cheaper to operate because it's passive market making, but it's also the worst for price discovery. And an exchange could be used for any kind of marketplace, whether it's trading token pairs, perpetuals, could be used for lending, for bridging, options, NFTs, prediction markets, or even tokenized stocks. So this is, this kind of technology could be used to build many types of marketplaces. And so just to give you guys an idea, I spent, before working on Lighter and kind of building in the space, I spent a bunch of time doing high frequency trading at Citadel and other places. And just to give you guys an idea, like the way what that looks like, right? I mean, there's thousands of orders happening per second, usually 100 million orders per day or more. And most of the orders are canceled and replaced. So there's a lot of activity. Percentage of orders that are actually filled is usually around 1%. But the reason why all this activity is happening is because market makers are competing with each other for the best prices. And as long as anything changes, it's to their advantage to quickly update their positions and their orders. And so this is actually the best possible experience for consumers because it leads to very low spreads, and you have liquidity kind of in any market environment for any asset. And the most important guarantee for consumers, if you think about like how do you ensure trust, I mean, besides the basic ones like asset custody and trade verification, the most important one is what we call verifiable matching, right? Which means like, can you cryptographically guarantee that, to put it simply, you're not screwed over when you send a trade into the market, that you're going to get a fill that's at a fair market price. And so, as an example, AMMs are verifiable, but they don't actually do matching. So what happens is cryptographically verified, but the price you get may not be the fair market price. It's subject to MEV, it's subject to sandwich attacks, and so on and so forth. Centralized or hybrid exchanges do matching, but not in a way that's verifiable. If you send a market order out there, you don't really know that it was matched with something at the top of the book and in the priority that you sent it in. It could have been matched with something somewhere else in the order book. You might be getting a price that's not the fair price, and you wouldn't even know it. Now, this problem, a lot of people have thought about this. The hard part of it is like, how do you do this in a way that has this property, but it's also cheap and fast as centralized exchanges, yet has the security of Ethereum? And that's what we've been working on figuring out, with ZK Lighter. So basically, the solution we came up with is, and this is a very general solution. Like I said, it could be used for many types of marketplaces, but it's an application-specific ZK rollup with custom ZK snark circuits. So, and I'll talk about some of the architecture decisions in a minute. But what ZK Lighter has is a verifiable matching engine that generates succinct proofs, and this is where the ZK snarks come in for price, time, priority, order matching. So, in other words, it's guaranteed that when you send an order, the order was matched fairly, right? And it has all the other properties you want, being scalable, secure, transparent, and non-custodial. So, one of the things that we introduced as part of this is a new type of data structure, an order book tree data structure, which basically it's a tree that stores the bids and offers in the order book in a way that inherits the properties you want from a perfect binary tree and a Merkle tree. So it ensures proper price, time, priority of order execution, and because of the Merkle tree aspects, is able to efficiently generate proofs of the order matching. So we made a couple of architecture decisions here that were key to this initial version of ZK Lighter. So one is, building these custom circuits, or using a ZK VM where you could write code in Solidity that operates an order book, and that's also verifiable, but the performance is much, much different. Even, and the ZK VMs have been making a lot of progress, but even in kind of the state of the art of that tech, the performance we can get from custom circuits is 10,000 times cheaper and 100 times faster. And so that really is the same kind of performance as you'd get from a centralized exchange. Another big decision was, do we launch this, because this is an app-specific rollup, do we launch this as an L2 directly on top of Ethereum, or as an L3 on top of one of the existing L2s? And we made the decision to launch on top of ZK Sync Era L2 because we're inheriting some additional properties there in terms of cheap proof aggregation and the way they handle state. So this makes the basically, if we weren't doing this, it would be only 1,000 times cheaper instead of 10,000 times cheaper than a simple Solidity implementation. So an extra 10x benefit. Another big decision is in terms of data availability, right? So if you, again, going back to the point that when you have kind of the sufficient market of high-frequency trading, most orders are not filled. Most orders are canceled and replaced. And so the question is, what happens to all that data? Certainly, the actual trades need to get posted on the base layer, but we made a decision that it would be, as long as the proofs that the orders were matched correctly are published, like the actual individual orders and cancels can just live on the L3. They don't have to be published, in the rollup, and this saves a lot of cost as well. Finally, a decision was made around, what proving system do we use? Groth 16 has some challenges around like the one-time setup, doing the ceremony, but once you do that, the costs of running it are still about 4x cheaper. So this decision also is part of how we get to such low cost of performance. There is that one-time setup complexity, but these circuits, we're not planning to change them very much. So once that happens, it'll kind of work from there. So in terms of the next steps here, right? So this week, the testnet for ZK Lighter will be live, and we look forward to seeing what folks build on top of it. Our team is building 2 products on top of it in the coming months, which would be for trading spot and perps, but it could be used for any kind of decentralized marketplace. Kind of the next steps beyond that, there's some really big problems to tackle here, right? So one is decentralizing the sequencer. And a lot of rollups are working on this, right? Obviously, the L2s and an app-specific rollup like ZK Lighter would need eventually to decentralize the sequencer too. We're actively working on this next because that's kind of the last step here. You know, the sequencer already has all these nice properties around verifiable matching. I think to prevent any kind of MEF to happen even at the millisecond level, and to introduce things like time lock encryption, you know, doing that in a way when the sequencer is decentralized will be a hard problem. So if there are folks who are working on problems of sequencer decentralization, you know, MEV resistance, time lock encryption, we'd love to collaborate. Definitely come find us at the conference. Another aspect, I mentioned the trade-off we made around data availability. There's a question of, for future versions, does it make sense to have some data availability, for the market makers or participants who do care about every single order and cancel that occurred? Like, what should the longer-term solution for that look like, and how's that? Potentially what would the tokenomics for that data look like as well? That's a really interesting problem. And then the last one is kind of thinking about for market participants who are not able to trade, basically who love all the properties of the efficiency, but the only reason they want to trade on a centralized exchange is because of KYCML. I mean, with a lot of what's possible with ZK, you can also do on-chain KYCML. So, folks working on that, we'd love to speak to as well and collaborate on that kind of for future versions as well. So, yeah, so those are kind of some of the next steps. Any questions, come find us down here. Our white paper, here's the link. We're publishing it now for the first time. We've had a couple of folks review the paper, and it's been really great to get feedback from the community. Now it's published, and definitely email us as well if you're not physically attending the conference and have questions about it. We'd love to address those and discuss possible ways to collaborate. That's all. We'll be down here to take any questions if you guys have them. Thank you.
the our LRTs like there's now re-staking, which is just anyway, we can go.
Stuff like that.
Yeah, literally right in your face.
All right.
Wow, this was working. Yeah, it's working.
Oh yeah, you'll have to hold it.
Yep. Okay, perfect. Okay. No, we're gonna have a long conversation. I can tell. This is about to get very deep. This is gonna get very deep.
Can we hear more?
Okay.
Can we hear more from the others? Like, is there a monitor somewhere? Okay. Oh. So speak loud. Speak loud.
I'm about to speak very loudly. Okay. Okay. Hi, everyone. We're very excited to chat about the state of staking today. We have a panel full of the experts in our industry about staking. I'm Dylan Olivia Hunziker. I'm the founder of a company called Apparatus. But today, what we're going to do is host a lively discussion and potentially a lively debate about certain aspects of the staking business and industry in crypto as a whole, and specifically within the Ethereum ecosystem, but potentially more broadly as well. Okay, we're going to have each attendee and speaker introduce themselves.
I'm Raul. I'm one of the co-founders of Diva Staking Protocol. We are a liquid staking protocol based on DBT, and we should be hitting mainnet in 1.5 months or so. We are now going through the audits of our smart contracts and actually the whole architecture. And yeah, basically it's that. Liquid staking protocol based on DBT, our own solution. And yep, that is pretty much it.
Hi everybody, I'm Darren Langley. I'm from Rocket Pool. I'm the general manager of the core team. Rocket Pool is a decentralized liquid staking protocol. We're actually the second largest liquid staking protocol, just behind Lido. And we've been around for a long time in the staking space. We have a liquid staking token called rETH, and we also allow people to do node staking as well, kind of permissionlessly from on the other side. So to kind of match that. Yeah, that's me. That's me.
Hi everyone, I'm Kenan Besic from Chain Security. So what we do is basically we audit smart contracts. We're here for the security. We're trying to contribute to the ecosystem by reviewing smart contracts. And yeah, we have some experience also with liquid staking. We have reviewed protocols. So yeah, that's about it.
Hi, I'm Freddy. I'm the Ethereum ecosystem lead at BlockDemon. And BlockDemon is an institutional Web3 service provider. We cover a wide range of products for our institutional customers, which is staking. We have an institutional wallet. We provide data and RPC. And really our institutional customers range from TradFi banks to foundations and more Web3 native kind of entities. And yeah, happy to discuss it all with you.
Yep. So the first question that I want to ask is what everyone has been talking about actually at this conference. And I want to talk about the launch of EigenLayer, and I want to talk about restaking and what some critiques potentially are, but then also what are some benefits and what EigenLayer's launch actually does both to the staking industry as a whole, but then also how it fares for your businesses and just kind of a deep dive into that part of the ecosystem.
Well, regarding Eigen Layer, I mean, my point of view here is, okay, is on the positive side, it is an innovation. Most probably, everyone within the ecosystem will end up integrating somehow with Eigen Layer in one way or the other. But on the other hand, we've been asking for the whole industry for such a long time to diversify and to offer different solutions. And now we are finding ourselves colluding within one single protocol, which is at the end Eigen Layer. Yes, because it offers a higher APR at the expense of actually potentially posing a higher risk for the whole Ethereum ecosystem at large. And my main take when I'm looking at Eigen Layer is why we were all kind of fighting against Lido because it was a centralization power, and now everybody's kind of extremely happy to be fully dependent of one single protocol, which at the end of the day, I just know what I've read under docs, but as far as I'm aware of, everything is upgradable by a committee. They are launching under a BASL license, which is totally fine, but that implies that they are thinking more on a business model case, not in making some kind of public good or something like that, which again is totally fine. But I think my perception of the kind of the whole community at large is like we are extremely aggressive and confrontational towards Lido, and we have taken kind of the stance along with the guys of Rocket Pool and other people like, okay, we have to make a diversified industry, and when Eigen Layer is kind of everybody's extremely happy just to have by having one single actor kind of controlling the whole risk and the whole real staking ecosystem, becoming a potential centralization factor, and actually adding an increased risk within the whole Ethereum network. So yes, I mean, I think it being something positive because it has kind of drawn all the attention against to the staking ecosystem, and actually has created its own ecosystem, which is a really staking ecosystem, and we all will benefit one way or the other. But on the other hand, I think it should be kind of treated by the same standards as the rest of the industry.
So from our perspective, the decision isn't up to me because we're a decentralized protocol, so it's actually up to our 3,500 node operators to decide what we do with Eigen Layer. From the kind of chat within the community, people are optimistically cautious, I would say, is the best way of putting it. On the positive side of things, our node operators are in a good position to benefit from Eigen Layer. They're also kind of a permissionless set as well, so on the flip side, we're actually really good for Eigen Layer as well. So there's a lot of value on that side of things. We do also see the value of expanding out Ethereum's trust network to be able to be used in other applications and expanding the ecosystem to create more decentralized products and services and applications. I think on the downside, there are a lot of open questions that we haven't really gotten answers to. We had an AMA with Eigen Layer a little while ago, and we're in constant talking to Eigen Layer, but there's some open questions that still need to be addressed. It's also the fact that they haven't necessarily launched yet, and we're already seeing protocols built on top of Eigen Layer sounding like they are launched.
Right, right.
When they're not.
Which is confusing.
Yeah, that's very confusing for the market. So that element of it is not necessarily good. So from our perspective, we are probably going to wait and see. There's nothing for us to integrate into at this point in time anyway. We will kind of like cautiously see how things are going, and we'll evaluate as we go. There's definitely some interest within the community. We've got proposals within the community to integrate Eigen Layer, and we will kind of like evaluate, the community as a whole will evaluate that and kind of like take it forward. But yeah, there's a lot of kind of things to think about.
So yeah, I agree mostly with the others, what the others said. So Eigen Layer, from the discussions I had so far at the conference, people are curious about it. So there's a reason there is a discussion. It's an interesting project. It's innovative. but it poses some risks which I believe need to be addressed in the discussion. For example, right, validators take on more tasks. What impact does it have on the validator software, right? There is some extra tasks, it requires extra time. What effect does it have on consensus, right? So I'm quite curious about EigenLayer. It offers cool opportunities like extra yield or bootstrapping basically this security aspect with existing liquid staking tokens that we restake, and it offers cool opportunities, but I believe, as you said, that there needs to be a discussion maybe also with other protocols to figure out or do research together to get to a good state. And of course, it's an additional component which offers, again, smart contract risks, and then protocols that build an EigenLayer that is not yet deployed, and then there is, again, smart contract risk, and you use smart contracts, so there is quite a lot of things involved that could break. And yeah, from the security perspective, it's super interesting, but also dangerous in that sense, but interesting.
Yeah, so we at Blockdaemon, we're super excited about EigenLayer and the innovation it's unlocking or will unlock. I mean, we do see a lot of interest, obviously, but yeah, it is early days. Like in any, staking protocol, it reminds me of some of those, L1 wars or starting to launch everywhere and nobody knows what it can do, how secure it is, how long it's gonna live. And so this is still early. For us, the most exciting part is to work with AVSs because, they're gonna need infrastructure, and that's what Blockdaemon is all about, obviously. And also, I think there's those implications that you mentioned for stakers. And then what does it mean? Like, do they understand the risks? How transparent do we need to make that risk? For example, we're currently sort of integrating EigenLayer in our staking flow, but that would, basically mean that the customers can, with one click, stake on ETH, restake into EigenLayer, and delegate to Blockdaemon running those AVSs for them as a node operator, which obviously from the UX perspective, which everyone is also talking, that's like the second biggest topic, I think, this year on this conference. But so that's great UX. But abstracting this away, those decisions away from the user is always sort of a trade-off in terms of security or in terms of even regulatory questions and things like that. So that's something that we're very actively monitoring. But in terms of what Raul said is, I think it actually could provide a thing with this additional innovation to, for example, mitigate some of those Lido risks, right? Because if, for example, like Puffer seems to be super successful in their vampire attack on Lido, if people really switch over from staked ETH to Puffer ETH, that would, sort of reduce that risk. And that, in that sense, I think, because EigenLayer opens up the whole ecosystem to more innovation and more things, that's why I would agree with you that, that it's like optimistically positive, like what do you say? Cautiously optimistic.
Yeah.
I think I like that. So that I think sums it up pretty good.
Yeah.
So what are each of you most excited about with your businesses?
Come again? What?
What are you excited about this year, but what is the biggest risk to staking as a whole as well?
Well, I mean, within the whole staking thing, we've seen a ton of innovation, as Freddy was mentioning. I mean, all the new integrations with EigenLayer, and with the whole restaking ecosystem, is bringing a ton of innovation to the whole ecosystem. Actually, it's been extremely competitive, and people are innovating one side or the other. Also, I think this year is a kind of the confirmation that the staking has become one of the key factors or key drivers within the Ethereum ecosystem or the blockchain ecosystem at large. And yeah, what actually is kind of making me really excited about the whole staking ecosystem this year is that everybody now knows about staking. Now it was like it was used kind of a last recourse for cautious investors. Like, okay, I don't want to go really crazy into DeFi and to, double down with a derivatives trading protocol. So I'm going to save some part of my capital within a staking. And now staking has evolved that much that that same investor doesn't really need to go to the other DeFi area or whatever, and just can keep the capital within the staking ecosystem, which at the end of the day is really good because staking is no more than securing the Ethereum network. So actually, we're bringing along more capital to infrastructure.
So it sounds like you're also describing a situation where your users are changing or growing, and you're going from one user base to another, or it's broadly kind of being accepted.
Everybody is, they are like my sons. They are becoming more mature,
Right.
I will say.
Okay.
Yeah, I can definitely echo that point. With the conversations that we've been having have been very, very different to like a year ago. The kind of players that are entering the market are much larger. You still got kind of home stakers and all that sort of stuff kind of going on, which is fantastic. That's what Rocket Pool kind of supports. But then you've got kind of like larger players coming in as well. People like crypto hedge funds and institutions and that sort of thing are talking about staking quite regularly now. So that kind of like demand side is definitely there. In terms of the exciting thing that I'm interested in is like on the innovation side. So Ethereum's roadmap has some interesting features coming that make decentralized staking protocols much more efficient, much more able to scale. So we're really interested and excited about that, and that we'll be using that in our kind of like roadmap to make sure that we can scale. And being a decentralized platform, we need node operators to actually spin up these validators. So that's always been a bottleneck for us, but with these new features and that sort of thing, and putting those to good use within our protocol, we can actually scale and compete with centralized providers.
Okay.
So yeah, for me, of course, the innovation brings more smart contracts, which I'm excited about. So that's obviously something, new approaches, like we have different kinds of protocols with different trust models, with different guarantees, with different smart contracts. So it's quite exciting in that scene. But let me think. I'm quite excited also about the upgrades, the network upgrades. For example, EIP 4788 introduces that you have the beacon block route, so you reduce trust in that sense, which is kind of cool. So I'm excited about the changes that or modifications that we're introducing to the protocol, so that we can create more trust to the end users, or that protocols can actually create a better trust model, because oracles, of course, often have failures or can be malicious or whatever. So I'm looking forward to that mostly, to reduce the trust assumptions or minimize the risk in that involved. Yeah.
Right, and I think what I'm excited about is that we see those improvements, and it's sort of basically maturing the base layer staking and making better, less stress assumptions for liquid staking protocols, or execution layer withdrawals, those kind of things, just that make life easier, both for us staking providers, but also our customers, the ultimate stakers. And yes, I echo that we obviously see a lot of institutions coming in here, and that's I think overall a great thing, because it also helps mature in that sense. I mean, there's probably there's two sides of a coin with any topic, I guess, but so that's exciting to us in the maturity sense. But then we also see those innovations, like let's say restaking or DVT or other things that are sort of push the boundaries, and that excites me in terms of, like, I thought sort of after Chapella, like everything is done in ETH staking, right? Because all the fundamentals are there. But I guess now I'm seeing this more as that was sort of the base stuff, and now we're moving one layer on top. And then we're having LRTs instead of LSTs, and we have restaking instead of staking, and we're going to have the L2s, and which also excites me, because it's all interconnected, right? We see those like with restaking, and then using this security for pre-confirmations, and that would enable maybe like based rollups or Ethereum sequencing or whatever it's called these days, right? And that's sort of another whole layer where we're going to see a lot of them probably accepting staking or getting security through restaking. Either way, there's going to be a lot more new protocols out there which need infra, which is great, and probably a lot of them also going to open up to staking, at least in the midterm. But that being said, because it's early, because that sort of reminds me back a few years when we saw all these other things, and we're going to see all those security questions. Is this going to work? Are consumers really understanding what they're getting into? So yeah, it's both more maturity and the crazy innovation stuff, which probably will be fueled in the bull market even more, right?
What are some explicit benefits versus risks of DVT? I know you were touching on them, but I want to get extremely specific.
So we're big fans of DVT because it eliminates the central point of failure, basically, in terms of the keys. That's great. But I mean, I guess particularly in the Ethereum space, we're always looking for decentralization amongst a lot of different dimensions. And DVT could be like not as diversified as we wish to be, much like what Raul said with the restaking thing. If that's just one entity doing restaking, then that is obviously a centralization if it attracts a lot of capital, which to be seen, I would say. Once the airdrop is done, maybe the capital goes away somewhere else. But but the same with DVT, right? Like all those DVT protocols, at least we have a couple, which is great. But if they, for example, have only one client or one implementation, then we're losing this client diversity that we're, finally, well, hopefully getting closer to on the Ethereum layer 1. So it feels, again, on that side, we will have to fight all those fights, or not fights, but all these discussions and innovations and work that has been going into that will have to come out on all these innovations that are building on top of the L1.
Do you have
from our perspective, there are kind of like two ways we could use DVT. Well, sorry, three ways. The first way is to help our node operators with kind of like making their setup more robust. So that's kind of one way. Although DVT is quite heavyweight for that particular purpose. There are other solutions that are probably a little bit more lightweight. Then the other thing is kind of squad staking, which is a group of friends or group of people that actually know each other that form a DVT kind of cluster together, and then they operate rocket pool mini pools via that process. And then the third way is actually integrating within the protocol itself. That last one is, we've kind of evaluated it and we've thrown that out almost for a couple of reasons. First reason, the main reason is that it's very, very difficult to apply DVT to a permissionless model. So if you've got people you don't know sharing the same kind of like DVT cluster, that's very, very difficult to do with DVT in a safe way. So we kind of decided not to go that approach because it complicates things. But at the same time, we're looking at using DVT for that squad staking use case, because that way, you can definitely get some advantages from that. But yeah, from a protocol perspective, we decided not to do that to reduce our collateral requirement. We've done it in a different way to be able to kind of like get that benefit for us.
Does anyone have anything else?
Yeah, maybe. I agree very much with the computation heaviness. It takes, again, time. It's similar discussion to the eigenlayer points I brought up. It's, again, another component, right, where you have to spend computation time, which can be always dangerous. And I also agree with the decentralization part. And yeah, regarding diversity, it can also be interesting. Like, you can split up your validator on multiple, like, continents. It ensures liveness. It ensures, like, safety from, I don't know, natural disasters or I don't know, weird politics where you get rugged by the government. So I find DVT quite interesting, and I also enjoy the approach that not everybody needs to start using every new fancy thing, right? Like, it's also part of diversity where people decide to go different ways, and that's why I appreciate actually having multiple also liquid staking protocols that offer different things. And then you as an end user, if you're interested, if the description is somewhat understandable, you can decide for yourself. So that's maybe my take.
I will just add that I pretty much love the way that you guys are approaching kind of the whole thing in case of Rocket Pool, because is at the end of the day we have considered kind of the same problems or the same issues. We are approaching them from a different point of view with different solutions. And at the end of the day, that hopefully that will provide the whole network kind of a more resilient infrastructure, which is at the end of the day what I think everybody wants. So I pretty much love that. Okay, we have evaluated this was kind of too complicated to be kind of fully integrated within the whole Rocket Pool protocol itself. So we decided, okay, we are kind of adapting on our own way, because I think that is kind of the best approach, because you are doing kind of your stuff and on a better way. We are doing our own. We are taking a higher risk, maybe kind of doing things a little bit more complicated. But at the end of the day, everything goes towards the benefit to the Ethereum protocol, which is fine at the day. And on the other hand, it also speaks to the benefit of this layer one of infrastructure, of a staking infrastructure, and it speaks a little bit against having just one single actor, as I mentioned before, in terms of eigen layer, kind of controlling the layer 2 over the staking side. So please, if everybody's building another eigen layer, let me know. Let us know, because we're really looking forward to it.
Okay, I have to confess something, Raul. I know the other firms, but I don't know Diva very well. And so could we talk a little bit about, like, just high level, how it's differentiated from the other providers on stage? And I know we've been touching on it the whole time, but I just want to make sure that you get that message out.
Sure. Well, first, thanks
You
a
haven't
lot
quite
for that.
launched.
Yes,
Yeah.
of course. I mean,
Yeah.
You haven't heard about us that much, or you don't know about us that much. First, because we are not live, so
Right.
it makes sense.
You could give some points to people, right?
Actually, we were too old-fashioned because we didn't go for points, and we just used old-fashioned tokens.
Yeah.
I mean,
okay.
kind of, we weren't that creative, I guess. And I mean, in terms of Diva, the main difference is that we did exactly what they discarded. I mean, we kind of integrated the DBT. We have developed our own DBT infrastructure, and it's I believe, the first vertically integrated DBT liquidity staking protocol. There is the main core difference. There is no way to interact with Diva without using DBT. So that makes a way more permissionless network. At the end of the day, I always like to speak about Diva like a network validation. And yes, that is kind of the main difference. The main thing that we are bringing to the market. Like, our main goal is to, everybody's kind of focusing on the staking side. How can we increase the APR to the stakers? How can we attract more stakers? Our main goal was to make validation extremely easy, so everybody kind of become a validator without needing that much of resources, in terms of resources, of economic resources and of computational resources. So that was kind of a little bit our core value proposition.
Great. Okay, so now I want to kind of throw it back to everyone. What do you see as the biggest challenge to your respective businesses, not to the industry as a whole? But I know that each of you are going to have very different answers, because there's definitely different critiques of each of your businesses, but yeah.
Freddy, you go first.
Okay, so the biggest challenge for us, I guess, will be deciding which of those new chains to support. Like, you know, we have L2s, we have L3s,
Right.
we have AVSs, we have...
So that was actually going to be part of my question is, obviously Ethereum comes first and is king. Obviously we're at Ethereum Denver, but what other protocols would you prioritize as well in the following kind of calendar year? Yeah.
To be seen, actually. I mean, we're multi-protocol. We're already supporting 60 different protocols, right? But, you know, I would just take a wild guess. There's going to be 100 protocols launching this year.
Oh, for sure.
So, you know, which one can we support, and which one do we want to support, and which of them are serious and will gain traction, and maybe even the non-serious one will gain traction because they have a great meme or something, right? So for us, that is, you know, a challenge in terms of, you know, setting this all up and running it as reliable as we do with all our other protocols. So that's like one challenge. And then the other part is those integrations. Just like, you know, Raul said, they went for full integration of liquid staking with DVT. And I think that's great because it, like all those innovations allow for new innovations and more, you know, everyone finds its niche and its own approach to certain things. And I think that, you know, let's say different approaches is what makes the whole ecosystem more resilient.
Right.
And gives everyone, and it's like of any industry that is maturing, you know, I think it's a healthy sign because in all major developed industries, we see those specialization of labors, very specific positioning for various players. There's always various players for each different topic or something. And so in that sense, I'm very bullish about it. And, you know, those questions that we face in terms of what to support and how integrated do we want to see this is a luxury problem, right? Because we're not talking about Ethereum killers anymore. It's all happening on Ethereum, basically. So that's great.
Yeah, for us, yeah, we're not building, right? Like, we're not the builders, so we don't face those challenges. We're not providing the infrastructure, so we're not facing those challenges. But for us, I would say the challenges are also related to multi-chain, right? Like, there's different mechanisms, there's different protocols on different chains. They have to adapt to the chain. So this overhead, of course, of information, you have to process that always whenever you review something. And then you have those protocols, right, like Diva, for example, which integrate then also with the clients. And there you have additional components which are now maybe not smart contracts, right? And then you have to familiarize yourself with other things. And I would say that's the biggest challenge, is difference in approaches, not be biased by some other protocol. And yeah, the experience we have is that it typically works, but it's always this learning curve you have in working, right?
For us, in terms of challenges, we've got a huge demand for RETH, which is our liquid staking token, and we need to kind of like satisfy that demand with supply for node operators. So it's kind of how we scale our protocol to take on, to be able to essentially mint more RETH and stake more, and kind of stay decentralized and kind of safe and all that sort of thing. We've got 2 major releases coming up in the next kind of year and a year and a half that kind of address these problems. So it's going to be a really exciting year for us to kind of be able to address those and scale kind of much larger, up to the point where we've said that we will stop. And so yeah, that's going to be fantastic for us. Houston and Saturn are the 2 releases that we're releasing. In terms of what chains we support, our liquid staking token can be on any chain, and it operates the same way. So it doesn't really matter what chains we support from a liquid staking perspective. But ultimately, we choose L2s because they build off of Ethereum. We like that security model, and so that's why we've kind of like chosen that. Particularly rollups, we prefer that security model. So the community tends to favor those. Us as a team, in terms of staking on other chains and that sort of thing, we are an Ethereum-based team, really. Right. We are a very, very small team, so we don't have the capacity, really, to go into other chains. And to be honest, the engineering uplift to go into other chains just isn't economically, and to the amount of economic gain that we would get out of it is much less. So Ethereum is much larger from an economic perspective, and so the engineering effort isn't worth it for us. That's us.
Well, our biggest challenge, obviously, is getting this thing to mainnet first. And and after that, I think the whole ecosystem, I will say kind of the biggest challenge, not just for us, but for all of us. I mean, Rocket Pool and any actor, any layer 1 of a staking is kind of get away a little bit of the noise that the liquid staking is making and focus on making something really solid and technically viable. In terms of other chains, and from the liquid staking side, pretty much the same as Rocket Pool. We are integrating with other chains on the liquid staking side, attracting value from other chains. We have really good contacts with the guys of Base and Polygon Zero Knowledge, CKVM, sorry. And but we are also speaking with the guys of Scroll and with especially, I mean, L2s, keeping an eye on the roll-ups, of course. And yeah, but as from the validation point of view, we are really Ethereum focused, and I think it's exactly the same. And the demand of engineering capacity that you need just to be alive and to keep pace with Ethereum, it makes you, I mean, it's, at least from in our case, it's impossible to reach out to other chains in the short term, at least.
Okay, so we have less than a minute left. If anyone has any closing remarks, I just want to thank all of our amazing speakers, but if anyone has one last thing before, one last plug, everyone plug what they're doing again.
Once again, if somebody is building the, I mean, how can I frame it? Uniswap needed SushiSwap somehow. Lido needed Rocket Pool. Eigenlayer needs someone. So if you are building it, please let me know.
Yeah. So in terms of the Rocket Pool stuff, so the community are going through this big research phase for the next kind of next year. They're actually laying out our roadmap and discussing our roadmap and coming up with new ideas, incubating ideas. So now is a really great time to be a part of the Rocket Pool community and contribute to the future of Rocket Pool.
Okay, I have like 3 seconds. Yeah, keep building. I'm curious about your projects. I want to learn about them. It's super fun, and yeah, enjoy building.
I would hope that we see some new use cases that are bringing mainstream adoption, because I feel we see all those chains, all those restaking, all those innovations. We're going to have a lot of empty blob space, whatever. Because I mean, all this great infrastructure and innovation, it's all like self-referencing, and we need to make a difference in the world, basically. And for that, we need some more use cases. So that's
Totally
what I'm
agree.
keeping my fingers crossed this year.
Okay, thank you.
Yeah. Thank you very much.
Yeah.
Check, 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 mic check, 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 1, 2, check, check, mic check, 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 mic check, 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 mic check, check. Microphone check, 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 check. Check, 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 mic check, check, check. Check, check, mic check, check. Test, test. Test, test. Test, test. Check, check. Check, 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 check. Now I'm calling Parker. We'll see what he says. Okay. Test, 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 test. You're good on this? You're good?
Hello, everyone. Test. Test, test. Hello, everyone. We are going to start in a few minutes. Just take your seats and be ready.
The closer you are, the better.
Look like.
There you go. Perfect.
Yeah, look it up.
Good? Okay, cool. Fantastic, yeah. Now we're going to start it. When do we start?
Let them know that they will all have something to set them up for success. They will need to knowledge base.
Then I think 1 minute we can start.
Make an announcement now.
Test. Hello, everyone. Welcome to the first ever ZK Mini Summit event. Woo! We are so happy to have all of you here. And to give you some background, ZK Mini Summit came from a few brainstorming sessions with the idea of how we can give back to the ZK community. Today, for like 3 hours, we are going to have different topics with thought leaders of the space. But to set you up for success, we are going to start with a presentation or like a book reading of zero knowledge proofs, explaining like I'm 5. And for you to follow along, under your seats, you will find a bag. And in the bag, there is a book. Yep, that's it, Dustin. You got it. So I would encourage you to open the book and get ready for the first session. Let's invite to the stage Marcin, who's the Chief Protocol Architect at Matter Labs, and who's the author of the book. Woo!
Okay, thank you, folks. So yes, as Albiona mentioned, please check under your book. This book started a little bit as a joke when I was trying to explain zero knowledge proofs to one of the coworkers. Let him be unnamed for now. And something that started as a joke very quickly actually turned into like, hey, maybe we should make a real thing out of it. And that's how this book is created. So, as the title says, this is zero knowledge proof, explain me like I'm 5. So it will give you some basics to start, but you're going to need to learn a little bit more before you can actually create a real circuit. So just to get the expectations right. Having said that, over the next couple of minutes, we're going to go through the book. I'll try to do the reading part. There is not much text in there. It's mostly for children, so it's mostly focused on images. At the same time, there are some questions. Please do not hesitate to ask. I think we're going to have at least 1 or 2 mics. And also, there will be also questions available afterwards. So, without further ado, let's get into the book. And let's explain to you zero knowledge, like I'm 5. So, imagine, Albi? So, forget about zero knowledge, forget about blockchains for a second. Just let's go back. Children, let's go, imagine a zoo that has many animals. For zero knowledge, we actually called a zoo a circuit, and the animals are gates. Now, imagine we also had boxes. Basically, 3 types of boxes. There are boxes that have a hidden number. There's a hidden number in a wooden box. These we call the variables. We also have glass boxes. They also hold a number, but for glass boxes, you can actually see what's inside. We call them public inputs. And then we have stone numbers. These don't change. These are clearly visible. You cannot actually modify what's in there. And these we call constants. Now, we had a set of animals, and now each animal has a special power. Animals can look inside the closed boxes. And then, depending on the type of the animal, they can be happy or sad. For example, we have equal zebra. So equal zebra is happy when 2 boxes have the same value. Now, if they don't have the same value, equal zebra is sad. Now, the important thing here is you don't know what's inside the box, but zebra does. So animals can also look at the glass boxes, they can also look at the stone numbers. And as I mentioned, each type of the animal has a different mathematical expression tied to it. So we have not greater than crocodile. And the crocodile is happy when the right number is bigger than the left number. And this is where the first part of zero knowledge comes in, is you don't know what's the number in the bottom box. But you know that the bottom crocodile is sad. So whatever that number is, it must be smaller than 5. Now, the important thing to remember is you don't see the values, but crocodile does. Now, we can have far more complex animals. Let's say the spider can actually look at 4 objects at the same time. It's the if spider. If the top box is 0, it would like to have the left and the bottom box to be equal. If the top box is 1, it wants the right and the bottom box to be equal. So look, the spider is happy. So here's the question to all of you adults in the room. Can you guess what number is in the top box? Yes? No? Okay. So in this case, we call a spider a selection gate. Now the zoo has a lot of animals, right? We have beavers for division, squirrels for modules, caterpillars for additions, and many, many more. And we can put all of these animals into more complex setups, basically creating complex circuits. If all animals are happy, this means that the circuit is fulfilled. The thing is that we don't need to see the values in the boxes, but we can just look at the animals. And what we say is if they're happy, it's good. And we can almost take a picture of the animals. Remember, the picture will not reveal what's inside the boxes. It will show you what's in the glass box. It will show you what's in the stone numbers. It will show you the happiness of animals. It will not show you the contents. And we can call the photo of all these happy animals a proof. So basically, proof becomes a photo. But enough talking. Let's actually build a circuit to solve the real-life 5-year-old problem. how to make sure that my sister split the candy equally. So here's the problem. Your mother left some candy. Your sister decided to split it between you and herself. How to make sure that she did a good job? So here's a simple circuit that takes care of this. So mom's candy is on the left. You don't know how much she left to you. But what you know is that there is a squirrel on top, there's the modulo 2, there's the beaver at the bottom, there's the division by 2. There's some sister candy that you don't know. There's also the caterpillar ad on top. So if the circuit is correct, if all animals were happy, then whatever values you got should be correct. But let's take a look. If we actually zoom in, imagine your sister put numbers in these boxes. We don't know what number she put, but the one that I'm getting is not correct. The beaver is sad. She did something wrong. Actually, if you spend a couple more minutes, for adults in this room, spend a couple more minutes, you can actually see that there's a small problem with this, but I'll leave it as a homework. This actually means that sister gave you more than her. But anyway, you can take a look and try to prove it to yourself as a homework. But now if we go to the next slide, this is the positive outcome. Again, we don't know how much candy mom left. We don't know how much candy sister got, but if all animals are happy, this means that the 2 candy that we ended up with is the right value. Now, in practice, you probably heard about different ZK systems. Now, the way you can think about them is like different animals. You've probably heard about Plonky, heard about Halo. Think about them, same concept. Animals, gates, whatnot, they are just different types. And there are a lot of different provers. Because remember, the proof is the photo of happy animals. And there are different cameras that you can use to take the photo. You probably heard about snarks, starks, fries, KZGs. That's where it comes in. That's the technology that's used to take the picture. So next time someone's telling you, oh, I have a snark with Plonky, you're like, oh, sure, so you use this camera with these animals. Got it. Next. So now that we know the basics, let's talk a little bit about how these circuits are created. So you can imagine that there are zookeepers. So zookeepers, they create new animals. Let's not get into details how they do that. Let's say they just create new animals. And they create the scenarios. They figure out, okay, these animals with these boxes. Now, we call these zookeepers circuit builders or crypto people. And there are also visitors. So once circuits are created, the visitors arrive, and they can actually put numbers in the boxes. So if you're a visitor, you're coming in, you're putting a number in each box, and then you take a picture of the happy animals. If all animals are happy, this means that the values that you put in the boxes were correct. Again, you don't have to reveal to anyone what values you put. Animals are happy, values are correct. And the only thing that shows up on the photo are all the happy animals and the public inputs. And this picture is what we're calling a proof. Now, there can be mistakes. Right? A very common mistake is, there can be a mistake that zookeepers do. For example, imagine they put too many animals. This is what's actually called over-constrained. And in this scenario, you cannot come up with the numbers that make all animals happy at the same time. Like, look at this example. What kind of values can you put here to make both crocodiles happy? Answer, you cannot. This is called over-constraints, and you will not be able to generate a proof for such invalid circuit. There are also other bugs, like a missing animal. if you want to learn to earn $1 million, find the missing animal. I am not joking. The examples of different bounty hunting for ZK proofs are all about finding the missing animal that if it's not there, you can actually put fake values in the boxes. And all animals will be still happy because, again, if one is missing, you will not be able to get that, right? So this is a very bad scenario, and we call this under constraint. And in systems, it can lead to invalid state transition being accepted, invalid state being committed to blockchains. So when you try to explain to your kids what do you do at work, is I'm looking for missing animals, honey. Now, real circuits have thousands upon thousands of animals. So looking at the picture to see all of them happy or sad would be very slow. That's why we have Zeek. Zeek is a special animal. Zeek can actually look at the pictures of other animals and be happy if all of them are happy, and be unhappy if at least one of them is unhappy. So we call Zeek recursive proofs or aggregate proofs. That's a special power. So remember, it can look at the picture with lots and lots of animals and just be happy or unhappy depending on their whole state. So this means, but now, the tricky thing is that Zeek, one Zeek might not be enough because it can look only at thousands. But with millions of animals and huge gates, we can actually have Zeeks looking at other Zeeks. Meaning we can have Zeeks can look at a picture of themselves. So we have Zeeks looking at animals. And that's what we start getting into recursive proofs. In practice, for systems like ZK Sync, we can have Zeek looking at Zeek looking at Zeek looking at animals. So like 4 levels, out of curiosity. So that's why at the end, we have one Zeek to prove them all. One Zeek on top of the circuit to prove that if he is smiling, then all the Zeeks below must be smiling, and all the animals at the very bottom must be smiling. And this means that the whole state transition, all of these animals that we had at the very beginning, all these small transitions, they must all be correct. So this, checking that the last Zeek is smiling, is what we call proof verification. And this is what's done on Ethereum. This way, the only thing Ethereum has to do is to look at one Zeek. And that's it. So if you want to learn more, if you go to this link, you can actually see a web page with both the book and interactive quizzes. So you will find an animals in there, and you can put things in the boxes, see if they are happy or sad, and try to solve some of them. So with this, I want to thank you all. Thanks for coming. I hope this was useful. I hope that it's, as I said, it's a little bit different approach to how zero proofs work. You're not an expert yet, but please wait for 2 more books, Eli 9 and Eli 15, and then you will be there. So, thank you.
As you are exploring the book and learning about zero knowledge proofs, we are going to come back in 5 minutes with the next presentation, and feel free to come and ask us questions for the book or play on the website. Thank you.
you want a mic with a stand?
Yes, please.
You've been here already. You know how
Yes,
this
sir.
works. You know how this works.
Yes, sir. Yes, sir. Oh, we're hot. Okay.
Once you're going to speak.
Yep.
Go ahead and make it full screen.
Yeah. No. Can I see the slides? Can I have the slides up real quick? There they are.
I can see a lot of ZK hats in the crowd. Hello. Well, we are back with the next presentation with Nick, who is a senior software engineer at Matter Labs and who's going to present about dumb-ass crazy ideas for on-chain dApps. Let's give him a welcoming.
Now. Are we good to go? Are we good to go? Yeah. Ah, cool. Yeah, we're close enough. Hey everybody, my name's Nick. I am here to present, as Albie introduced, dumbass crazy ideas for on-chain dApps. Right? So, little intro about myself. My name's Nick. I'm a software engineer for Matter Labs. Here's my socials and website down there. I am relatively new to Web3, about 6 or 7 months in, and I'll sort of talk about that as I go through my presentation today. For those who want to follow along, this is a QR code to download these slides. We're also going to post these online, available after the presentation. But if you want to follow along now, feel free to scan this. Leave it up for a few seconds. Cool. So what am I going to be going through today? I'm going to talk about why did I do this presentation, and then I'm going to go through some of these ideas. At the very end, I'm going to wrap it up with some takeaways that hopefully we can all walk away with. So why did I do this presentation, right? Kind of goes back to I had first joined Matter Labs and I had $100 worth of ETH. I wanted to figure out a way to spend that money. I looked for a bunch of different games that I could play on chain. I am very passionate about gaming. I wanted to see if I could support the local developer community. If there's like an indie game that was available, I thought, you know what? I would love to give them my money. So I started going and looking through some of the dApps that are available. And honestly, they were not great. Most of them just ended up not working, or if they did work, were just NFT shills. It wasn't fun, and I just wanted something more out of it. So I started looking beyond gaming. I started looking at other kind of dApps that existed out there. They were mostly finance-based, or finding ways to swap tokens or trade NFTs, and it really felt like there was this lack of innovation that existed. It wasn't something that I, really felt passionate about giving my money to. And I wanted something fun, right? I wanted to spend my money, and I didn't know how or where to. So before going a little further into the presentation, I want to talk about my mental model about how I've come to think about Web3. So for me, I think about Web3 and specifically smart contracts as kind of like AWS Lambdas. So for those who don't know, AWS Lambdas are this serverless computing functions that exist, hosted by Amazon, and they're super convenient and easy to use. In the smart contract world, we have these calls and transactions. For something like an AWS Lambda, what that really equates in my mind to is, every call is a GET request. You're getting information. Every transaction is a POST request. You are making a change to the data that exists on chain. The difference here is who pays for making sure that these services exist. In the AWS Lambda world, it's whoever is paying for the Amazon account, your AWS account, right? You get billed at the end of the month. Smart contracts, you have to pay up front. You don't pay for the calls, the GET requests, but you are paying as a user the transaction costs, those POST methods. Now there are differences, right? With an AWS Lambda, you can invoke them with HTTP requests, with events, or even through a scheduler. That's not the same with smart contracts. You can execute them or start a smart contract function from an HTTP request, but there is no way to call a smart contract function from an event that has happened on somewhere else on chain. There's no way to just start and execute a smart contract function based off of a cron job. Right? It needs to be initiated by the user. Another limitation is you don't have the full access to the resources like you would with an AWS Lambda. In AWS Lambda, you have access to potentially gigabytes of RAM, but in smart contracts, we're talking about kilobytes. Right? You have to live within these sort of restrictions of the current system right now. And that sort of gets me to the next point, which is I'm looking at these apps, and we have this sort of constraints that are built into the system, these limitations. But from my experience as an engineer, I've always seen that these limitations often foster creativity. And I'm not seeing that. But let me sort of talk about what do I mean by limitation fosters creativity. So there is this amazing YouTube interview by Ars Technica. They sat down with Andy Gavin, who is the co-founder of Naughty Dog. This is the team who created the Crash Bandicoot series, and they wanted to go through the war stories of what it was like to develop the original Crash Bandicoot for the PlayStation before the PlayStation ever even got released. Right? This game launched at the same launch day as the PlayStation. So for them, they had similar restrictions. And their mentality, their philosophy at the beginning was no cycle of CPU, no GPU, or byte of memory would go unused. They would find hacks, they would find tricks to get to every single piece of resources that they could, whether they were supposed to or not. So one example of that was limited memory access. That's something that I had just talked about with Ethereum. And what was the case for the PlayStation was the PlayStation only had 2 megabytes of onboard memory on the console. Now, the disk of the game had about 640 megabytes. The game itself was about 60 megabytes, so most of it was like 90% empty. But the problem and the constraint was really this 2 megabytes of RAM, because the CPU and the GPU of the PlayStation could only ever access the RAM. It couldn't access the data directly on disk. Right? It just wasn't possible with the interfaces. It was too slow. It takes time to get data from the disk down to the RAM. So what did other companies do? They lived within these sort of boundaries. They built game levels that only had 2 megabytes worth of assets. So the original PlayStation games, the majority of them were very small. They had to fit in 2 megabytes. But what did Andy do and his team? They basically found a way to update the entire custom memory schema where they had 64 kilobyte chunks. And as you were walking through a game level, it would hot swap chunks of data that you would need directly from disk. So, in essence, by building out this hot swappable memory, you now had access to much larger game designs, much larger game levels. And they were doing things that no other game could at the time because it forced them to, right? So I ask, the dApp developers that are out there, what if you didn't have these constraints that we have currently with Ethereum? What can be done? So that gets into the first crazy idea, what I'm calling Z64. It is, what if you could have an on-chain Nintendo 64 emulator? Is that even possible? Right? So where does this idea even come from? Where did I come to this? Yes, I'm passionate about gaming, but why the Nintendo 64? And one of the things that I had mentioned before is this idea that anytime you interact with a transaction, it's coming from a user, right? So video games today, whenever you are trying to save a game, typically you walk through and it's just auto-saved as you go along, right? That's not how it used to be. Whenever you played these older games on the Nintendo 64, you had to open up the menu, you had to choose save, you had to click yes, and you had to wait as the game is being actively saved on memory, and then you wait for that transaction to complete, and then you go about your day. People were just used to that. That is the flow, that is the limitation that they were used to. That is very similar to what we're seeing right now with Ethereum and transactions. So what can we learn if we look at the Nintendo 64 and the game building model of these sort of similar interactions and restrictions? So I basically started from there, and it turns out it's kind of possible. The first thing I realized is that there is a WebAssembly emulator for the Nintendo 64. So it is called N64 WASM, by the way, if you go look it up on GitHub. But it allows you to fully, in a browser, emulate the Nintendo 64 and play games in the browser. I was like, all right, awesome. All I have to do is make a website and host that on-chain with this JavaScript. Cool. Make a website with BossGG. All right, now that's fully on-chain. All right, that solves that problem. I now have an emulator that is fully on-chain that I can pull up through the browser. Next problem. What if I need to save the game at any point in time? Well, it turns out to save a game is about 16 megabytes. This is a problem because approximately that's going to cost you about 32 grand just to save the game once. Now, it's still feasible, right? This is crazy. You probably wouldn't want to do this, right? Just for one single game. But it got me thinking, and I started talking about this with some of my coworkers. You could actually use a Validium. And actually, if you don't need this data to live on L1, which I don't know if you need your Ocarina of Time game save state all the way up to L1, it can just live off-chain, then these transactions go down to be pennies. Right? That's the majority of this cost, where it's coming from. So theoretically, you could have a fully on-chain Nintendo 64 emulator experience. All right, let's go into idea number 2. The burner phone smart wallet. So for those who are not familiar with what a burner phone is, it's this prepaid phone that you can buy typically for cash at a local gas station that people use and then throw away once it's done, and it's has a lot of implications behind it, but that's the general idea. Could you have that sort of experience? Is there, I don't know what the need is, I'm not going to speculate, but could you do this for your smart wallets, right? And as I start thinking about it, it's really, could you have prepaid gift cards for smart wallets where you can only put in money once, and then from then on out, the funds can only exit, right? Technically, it's possible with some things like account abstraction. You can control with logic the ingress and egress of your transfers. You can add business logic in there to say, hey, You can actually do this if you really wanted to. Idea number 3. What if your smart contracts changed ownership randomly? Now, that's really, really scary for some people because there is a lot of money typically associated with a smart contract, and handing over an ownership of that contract means you are now exposing and handing over the ownership of that money. But just leave it up to RNGs and it's totally possible. That's a terrible idea. I would not recommend this at all. But what if the ownership of it changed every single day? Did you just create like a lottery system by doing this? Right? And along the way, as I was thinking about how to implement this, I started learning about different ways for role-based access. Right? This concept of ownership can be defined in a few different ways. And there are different ways of having role-based access. Also, you would need to have some sort of scheduler, right? I had mentioned at the beginning, like you can't just execute a smart contract function fully on chain based off of a schedule. However, after going through some of the research, it turns out that there are schedulers that are available as a service. It will exist off chain, but they do exist. And I started going down this rabbit hole of, okay, technically this is possible. I don't want to do it, but it's possible. Another idea. What if there was an automated cat feeder based on ETH tips? So imagine you had an animal shelter, right, where there was a webcam stream pointed at a bunch of cat feeders. And on this website, you could donate or tip ETH, and that would automatically dispense some snacks, and then the cats would interact. This would sort of, imagine me, at the beginning where I wanted to spend that $100, I would love to have donated that money, right? It's going to a good cause. It's going to keep that animal shelter open. But it's also that instant gratification. Once that transaction goes through, you're going to see, oh, the food gets dispensed and the cats are happy and they're all playing and probably, might be fighting each other for the food, but it's rewarding and I know where that money's going, right? And the money that you're distributing for something like this, it could be used for keeping the website running, the power, the maintenance, anything else just goes to the animal shelter, like I described before. And who's to say this has to only be an animal shelter? For those who might have been at DevConnect in November, in Istanbul, there are a bunch of just wild cats that just roam the streets. They're totally friendly. They'll walk up to you. They're at most any park. But who's to say the same setup can't be set at a remote location where these cat hotels sort of exist in these parks? All you need is someone to constantly fill it up, and it's the same experience. And then I heard this whenever I pitched this to a few of my coworkers. So if anyone wants to do this, please feel free. Another one is this idea of a timestamp oracle. So what if on-chain you had your smart contract or your application had access to the current timestamp down to the 100 milliseconds? Right now, the only way you get access to a timestamp is what is the current block timestamp. Depending on what network or what protocol you're using, that could be a few seconds apart, right? It's not an accurate timestamp to what the actual time is right now. It's just when was the last block mined. And what you'll really need here is a network that can handle hundreds, if not thousands, of transactions per second. Because again, you're hitting this at 10 hertz, so 10 times a second, to be able to have that sort of frequency. But what could your application do if it had the most latest up-to-date current timestamp on-chain? Another thing that you might realize is this is going to get expensive. I'm making 10 transactions a second. I can't keep this up forever. Even if I wanted to sponsor an application like this, put in the funds, that's going to drain my account real quick. But that's when you start diving deeper into applications or networks that have state diff-based fee models. So with these sort of models, you start learning that, you only really get charged for the difference in the data at the beginning and at the end of your batch. So even though you're updating it 10 times a second, if the batch is, let's say, 2 seconds apart, you're only going to get charged for the beginning value to the end value. Another idea, what if your biometric telemetry, your health telemetry, is fully on-chain? All right, what if, similar to that timestamp oracle, it is constantly being updated and just available, right? What if, well, let's go into some examples. So what if you could prove that you exercised at least 3 times a week, right? Is that cheaper life insurance? What are some applications behind that? Is there any way to anonymize this data, right? That was the basic, as soon as I asked this crazy idea to some of my coworkers, it's like, I didn't want to do that. I don't want anyone knowing this information. That's very private, that's PII. But maybe if we anonymized it, that could work. What if also you use this as a reward system? What if you built an ecosystem where if you proved your heart rate was above normal for 30 minutes a day, then after a full week, you get a small prize pool that gets distributed between all your friends, right? And it incentivizes all of you to make sure that you're exercising at a constant pace and you're keeping each other credible as you're going through this. So here are some final thoughts. Here are some takeaways that I want to make sure that I sort of cover here, which is, one, get creative. Like these, don't constrain yourself to the idea of just the limitations of the system, right? Don't be afraid to share these crazy ideas. Something like a hackathon is perfect for making sure that you feel like you can just, try something for the sake of trying something. And Ethereum's ecosystem and the feature set is just expanding rapidly. So take advantage of it, right? State diff-based fee models or validiums or whatever all these examples that I went through, those are becoming a reality now. So understand what they are and try and use them. Another big one for me is we're better than just another finance dApp, right? None of these ideas were like finance-based, but I really cringe at seeing another just NFT shill sort of app that's calling itself a game. And lastly, like asking these crazy questions or crazy ideas is going to help you learn something new and think differently. Whenever I bring this presentation up with my coworkers, I left every single time knowing something different. Whether it was, hey, that actually existed about 2 years ago with this one side project, or hey, actually that might be possible now because we're going to have something like validiums. So, one final note is ZK Quest. For those who haven't signed up, it is a web app that we built just for ETH Denver, where you can go and complete coding challenges and puzzles to earn ETH. This is something that we sort of built together as a different approach to hackathons. So if you want to sign up, the booth is going to be here all week. It's going to be down that way. You probably have already seen it. And thank you.
Yes. Another round of applause for Nick and amazing ideas to build on chain. Thank you. Thank you. We'll get ready for the next slot, and the next slot will be a panel with thought leaders of the space. But as we get ready for that, look out for the Zeek hat team members of Battle Labs. We'll give away Zeek hat around the team. So look out for Dustin here. He's giving away swag. Don't forget to get one of the hats. You will need to finish ZK Airport. But this is just a gift for you that you are attending the ZK Mini Summit. Thank you. We'll see each other in a few minutes. Hey everyone. I hope you're having fun and waiting for the next panel. We'll start in a few minutes, just to let you know. Thank you.
I'm on the stool. That's not very good. Let's see if I can move this. Why did they give you a stool in the middle? As all of it is so comfy. Benedict can have a chair.
That's good.
The bright lights. Ah. Just a very smooth shade. There you go. Yeah, they're not that close though. Hello. And there's no monitor, so to hear each other, you might have to kind of speak up. All right. Do you think it is a football game or what's going on there?
Yeah.
Yeah. Halftime. Is there a halftime show?
Yeah. Okay. Cool. Yeah. So
Should we start with the spicier takes? What should we do?
Well, we should
ignore Porter for a while.
I mean, like just topics where we disagree would be good. You know, because I think we all like ZK, we all like scaling, we all like privacy. But this is actually the reason for the timer at Summit. It's ZK boxing. It's the new sport. Like you've got someone from Polygon, right? Like a fighter, a second, right? Because they're going to come on after we talk. I'm very jet lagged. So what's it like moving from Brave to the degenerate world of Web3 and cryptocurrency?
Well, I mean, you know, at Brave I was kind of being slowly sucked into the, you know, abyss, if you will. But yeah, things are different.
Yeah.
You're just going to be a little awkward. It's like all by yourself already. Yeah, but I mean, I can give you a long answer if you like, but we'll have to do it later.
I mean, I imagine you've thought about this a lot, and like I don't know the specifics or the details of it, but like, what do you think about turning, you know, like what Brave was doing was a basic attention
That's
token,
good.
kind of just turning that into a more cross-browser protocol instead of it being browser specific.
Yeah, good. I mean, it's just
do you think that would help it gain some kind of traction? Oh yeah.
It's people can hear me now. Hello, hello.
I'm not convinced of that. I think that's well again. Let's talk after this, right? But
yeah, of course.
it's a complex problem. It's a complex problem. And it's a problem from somewhat of a different age, a different cycle, crypto cycle as well. So kind of complicates it a little further. Let's say.
Fair enough. It's a valiant effort, though. I mean, we do need better monetization.
Porter.
Jason.
Hello.
Huh?
Hey, how's it going?
Hey, good to see you.
See you.
Oh, if you want it? Yeah. Okay, take it.
You've got a pet.
Is there a stool to the left of you? What? That goes on a stool to the left of your chair. Oh, you can keep it, yeah. So you just
pass that around. Whoever's speaking has to hold the whale.
I'm sorry, I didn't mean to separate you.
Yep, good. He's getting pressure here.
ZK safety win.
And we are back with the next panel. Thank you very much for your patience, everyone. Let's get a round of applause for everyone who joined us today. Woo! This panel is called ZK Snarks Rule Everything Around Me, that Vitalik presented at EdCon in Montenegro, and we were very inspired by that. That's why we decided to bring thought leaders of the space, starting with Jason, Zach, Ben, Jordi, and Benedict. Porter will be the one who's hosting the panel, so let's just welcome them again and let's hear what they say.
All right, welcome everyone. I'm super excited because basically the way this panel was created was I got to ask all of my favorite guests and they all said yes. And we're gonna talk about how ZK will rule the world. But first we will do the slightly boring intros. So if everyone could just say your name, introduce yourself and your project.
Yeah, I'm Jason Morton from Ezekiel. It's a project to make AI verifiable and private with ZK.
Cool. Hi, I'm hello. Yeah, I'm Zach. Does this need to be a boring intro? Extra boring? Who here's heard of Aztec? Yes. So yeah, that's my jam. So yeah, I'm a CEO, co-founder, and our mission is to add strong privacy guarantees to this wonderful distributed world computer that we're all building and using.
Ben Lifshitz, VP of Research at ZK Sync.
So I'm Jordi Bailina. I'm the technical lead at Polygon ZKVM. We're trying to just scale Ethereum. That's the main goal. And yeah, and very much a developer, engineer, and Ethereum fan, I would define myself.
Yeah, my name is Benedict Bunz. I am one of the co-founders of Espresso Systems. We're building a shared sequencer for ZK rollups, but also rollups in general. And you know, I have some takes on where ZK actually doesn't rule everything, where you need other tools such as consensus to solve some issues. But I also have a second hat. I'm also a professor at New York University, where I work on zero knowledge proof. So I also do believe that ZK will just rule a lot of things.
Nice. Welcome, everyone. So we will have some spicy takes. I know a lot of these people have been on a lot of panels before, and I don't want this to just be another boring panel. But starting off, we're going to...
All those panels were very exciting.
Right. Sorry. Very exciting panels, and we'll swap seats around, and then we go speak the same stuff at the next conference. But anyways, let's zoom out, and let's go 20, 30 years in the future. And I want you guys to imagine all of your dreams come true. ZK has taken over the world, or however much Benedict wants it to. And so like your engineering goals are hit, like all of the things that you want to happen. What does the world look like at this point in time?
Sure, I'll start. So one of the things we think about is not just AI, but kind of general analytics that can be done in ZK. I think one kind of final scenario for ZK is that it completely replaces all of the kind of ERP databases, everything that lives inside and between companies. And so every time you look at a financial statement on Edgar, you know that that number underneath it is a proof of every single transaction that went into that number. And I think that would be an interesting new foundation for the economy. It would allow a lot more trust as well as confidentiality, but trust in the numbers that were presented in investments and in other decisions that we make.
Yeah, good answer. What is blockchain really for? I would say that it's a coordination engine, and it's trust infrastructure. And at the moment, it's a very primitive, limited coordination, and it provides limited trust because of lack of strong privacy guarantees and limitations with scaling and data. And ZK can solve all of these. So where are we going to be in 20, 30 years? We're going to be in a world where it's much harder to create a monolithic company that leverages its profit through information asymmetries. If we succeed, I hope we create a world where users are much more in control of their own data. Once that becomes practical and possible, I suspect that there's going to be a strong push to make it inevitable. People are going to be much closer to the institutions and structures that they are governed by, and will ideally, if not themselves actively participate, will have an expectation of being able to do so, which means having a more pluralistic forms of governance, both politically and socially. I see it as a world where it's much harder to create monopolies, a world where it's much easier to start competing in industries because everything will be much more composable, and barriers to entry will be much lower because of the composable nature of what we're doing. But ultimately, it's going to be a society where there's more trust. It'll be a strong trust society, not a weak trust society, which is where we're heading at the moment, where people don't have trust in their institutions, and they don't have trust in the governance structures that they're subordinate to.
I mean, look, so fundamentally, this is about building an affordable, high-integrity computational layer with optional privacy in a way that cannot be exploited, right? It's a bit of a mouthful, but that's sort of, at the end of the day, that's what these systems become. And certainly we already see enough of sort of traditional finance functions being moved to that. But I think it's going to be super interesting to watch as we have sort of users other than like humans actually starting to step into the space. That is to say, you have agents, autonomous agents, things of that sort, programs that react to data. I think that's where, you know, basically this high integrity layer will start shining, and where the demand for higher capacity, for higher throughput, potentially lower latency, where all of these things will become even more important than they seem now.
Yeah, you know, it's more philosophical, maybe answer here, but I believe in a free world. When I say free world, is free people living in there, people that just live happy, that has some happiness in there. People organized in communities, not in states or not in these. So communities that you can choose to opt in or to opt out. And for that, you need some system of trust that you don't need to trust in specific persons. You just trust in numbers. I think you were mentioning very much before that. And yeah, to create this community base where, I mean, people just think in having fun and working for the other peoples to have fun and enjoying where we are living in this world. Yeah, we need to solve conflicts that the humans have today. And if you do a deep analysis of what are the big problems that humanity is suffering right now, most of them you will discover that end up being trust problems. If we can solve that, or we can add a piece, I mean, if we can add or piece so that the trust of humans is less needed, and we can trust in math, in science, I think this is we will get a better world, and that's my goal for my life. I mean, but I don't know if it's going to be 20, 30, 50 years, whatever it is, but this is what I'm working for.
Yeah, I'm not sure I've met Chad. I would love to live in all of these worlds, but yeah, I think one very concrete thing that I don't think will take 20, 30 years is that there's a lot of generative data, you know, with the advent of AI, and I think that sort of necessitates more like sort of verifiability of where that data is coming from. And I think that's a very immediate problem that we're facing, but that I think is very solvable using ledgers and using zero knowledge. But, yeah.
Nice. I think it's actually a great summary. All these visions are really cool, and they actually do seem all really solvable. Like, you guys are all working on projects that directly do this. So is there any reason why these futures wouldn't work out, or any roadblocks or bad things that could happen along the way?
Yeah, I mean, I think one of the roadblocks that we face every day, maybe not so much here in magical Ethereum land, but if we try to sell this to someone outside, who's not here in Denver with us, is that they have a trouble understanding what exactly it is that we're doing, what the guarantee that we're providing is, and whether the trust assumptions that we've now made are actually better than the trust assumptions that are provided by like a trusted enclave or just by a legal contract. And so I think the biggest barrier in my mind is not really technical, because I think we've shown that the technical innovation can happen at an extraordinarily fast pace. So the real barrier is more social and educational and kind of marketing. Can we figure out a way to explain the benefit of this technology such that everyone can understand it, right? We've done a tremendous job, for example, with HTTPS, right, with secure socket type technology and certain kinds of very limited encryption. But outside of the crypto space, people don't even really feel comfortable with the digital signature, and we're asking them to understand a generalized digital signature. So I think we have a lot of work to do in making it seem useful to the average person.
Yeah, I'm not sure I agree about it being really about education. I think the fundamental issue is the tech sucks. Like, it's so bad. Who has tried to write ZK snark circuits? Come on, raise your hands. Right. Who's deployed ZK snark circuits in any kind of production setting? Yeah, it's fucking hard. Sorry for swearing. So I think, yeah, people don't understand it and it's unfamiliar, blah, blah, blah. That's because it's weak and it doesn't reach into their lives in a meaningful way. And we have a lot of work to do there. But that's not why we aren't going to succeed, because technology is inevitable. There are so many reasons why we'd fail. Let's just look back to the first generation cypherpunks in the 90s, right? The battles that they fought were around ensuring strong encryption was available to protect user data. And so they had to have a fight to legalize encryption software. And they won all these battles. And, but the war that they were fighting was a war for an open, permissionless internet where information was free and humans would be their own autonomous agents surfing the information superhighway. And my God, did that not happen. We're all bloody commodities. You're a commodity. What's the sum total of your commoditizable information versus the amount of money that black market smugglers could get for your organs? I reckon the information might be more valuable at this point. You're not the customer, you're the product. For every single goddamn application that you use online. So the cypherpunks failed. And now, look at us. We're talking about, we're going to change the world. We're going to create this wonderful world of free agency and democracy and openness. This is a $1 trillion casino. None of what we're doing is reaching into the lives of the average people, ordinary people. Nobody buys their daily goods and services with cryptocurrencies unless they're very technologically well connected. Bitcoin is not the kind of threat to sovereign currencies that its creators intended. And there are so many difficulties with pulling out any kind of positive utopian vision, I think, out of the relatively corrupted, flawed foundations that we've had to build off of. So what are the problems? Privacy does not get accepted. We as in the entire community just can't make it work in a way that users are willing to tolerate it. I'm wrong with my thesis that privacy is the missing link to make blockchain reach into the real world and become mainstream. Without privacy, we are building the tools for the next surveillance state. We're building networks where every single transaction is happening on a global permissionless, so for now, ledger, where everything is visible, where the sum total of all of your transactions and all of your payments, what you own, what you have, is viewable by all. What the hell? Everyone's like, oh yeah, privacy, yeah, we'll add that on later. It's just an easy fix, it's turnkey. Are you mad? We're building dangerous technology masqueraded as a dumb casino at the moment. And we're just repeating the same mistakes as the Wave 1 cypherpunks, the way I see it.
But what do you think are the mistakes? Because I don't know, a product that I think about sometimes is PGP, just encrypted email, right? Which is not very technically hard. What we're trying to do with zero knowledge proofs is significantly harder. It is absolutely awful, right? No one has ever used it. Seriously, it could be the default. Your emails could be by default encrypted in some way. I feel like that wouldn't be that hard to do, and yet it doesn't exist. And I'm not entirely sure what the reason is. Is it hard to is it hard to deploy, or is it I don't think it's evil Uncle Sam trying to prevent it. I genuinely wonder why not, and how can we learn from these failed attempts in the past?
I can hazard a guess. It's that the problem is society benefits as a whole when people use these technologies that are backed by strong encryption. For the individual, it's a meaningless difference. You take some random person, so just some average Joe, right, going about their lives. Do they care about their emails being able to be read by the government? No, and they don't even know that can be the case.
Not entirely. I mean, so just about every survey you do in privacy, you'll basically have this sort of 10, 80, 10 kind of thing, which is 10% don't care about much of anything, then 10% are sort of the tinfoil demographic, and then 80%, sort of negotiate with me, right? So basically depends on the circumstances and depends on the value prop. And then, there is a bunch of products out there that are quite addictive, where the value prop is that people are willing to give up on their privacy to get, free usage, right? Or seemingly free usage.
I think that all the technologies, I would say, quite neutral by itself. I mean, all the technologies can be used for good and for bad. But the technology, I mean, if we think that the technology is a bad thing, then we would not advance. We would not do technology. And if we think that the technology is a good thing, then maybe somebody is going to take over. So we need to understand that all the technologies can be used for good and for bad. And it's our responsibility, and here I fully agree with you, Zach, is that it's our responsibility that this technology, as it grows, it's also used for good things. It's used for improving the good of the humanities. Of course, there are risks, and I agree that we need to be aware of the risks. The risks that you mentioned, they are facts and they are reals. Okay, so we need to be aware of that, and that's why supporting privacy is an important thing. But the technology is not only. This technology is not only privacy. Scalability is important, usability is important. There are other things that are important and needs to be improved. And when you join all together, all the pieces, of course, including privacy, including censorship resistance, including all the values that are important, if we put it in the right way, we will get a better society. If we put it in the wrong way, we will have a worse society.
I agree with that. I'm saying that without privacy, it is a worse society. As in, transparent, distributed ledgers, I would argue, if that's the end state, they are net negative on this planet. Net negative, because of the amount of social control that can be exerted by having perfect information transparency around individuals' resources, what they own and how they spend them, is far too damaging.
I think to take a slightly different take, I think part of the problem with privacy, as we're conceiving of it right now, is if you try to sell privacy to an individual, you have this problem: they don't care, it's a lot of work, and the government would actually rather that they not have it. But there are plenty of other actors in society that have an actual obligation, right? So they have an obligation under regulations to keep user data private, or not to collect user data, or not to keep it. And so I think if we focus our energy on kind of companies that have to maintain confidentiality, companies that have to use their users' data in some specific way, we might have an easier time actually delivering privacy to the end user.
Let me be a little bit controversial here with you, Zach. I agree with you in the privacy, you know that, but I would prefer a world where all the transactions are public than a world where very few people and people that you don't control have access to your transactions and not the rest of the world.
Yeah, but that's not where we're at the moment. At the moment, everyone's transactions, it's a melange of chaos, right? We have cash, we have an enormous number of differentiated payment platforms where it's actually quite difficult for, at least in a nominal democracy, for a government institution to actually have perfect visibility over an individual and their assets and their finances. Especially not in a very algorithmic, deterministic way where you can just run a query and on anyone and get that information.
Please don't misunderstand me. I truly believe that we need privacy, and privacy is a value. It's a fundamental value in the space, and we need to solve privacy. Okay? But said that, I prefer transparency, which is another property that we are adding here. It's also important, and it's also a value that's interesting to have.
I was just going to say, look, let's not forget that the public blockchain use case is not the only case that's out there, right? The situation is very different if you start speaking to banks, corporates, consortia of, car manufacturers, people who deal with logistics and all these other use cases that in some cases, go back to 2018, 2019. Those people, to them, privacy is very much needed for all sorts of reasons that have nothing to do with personal freedoms, that just have to do, they make good business sense, right? And then you don't have to sell them on that. They understand why it's needed.
Yeah, I agree. I mean, these are all tractable problems. I wouldn't be here if I didn't think that. But it's a challenge that needs to be considered, as in the way that we're planning on going about it is not, like, privacy is not the, it's not the product, because not enough people care. Privacy is something that is an essential requirement for certain products and services whose value prop is completely unrelated. And those, I think, are the targets that need to be chased in the early days.
But Zach, the other point is that we are the starting point right now, and regarding privacy, currently we have zero privacy. The starting point.
That's not true. That's absolutely not true.
Look, maybe we had privacy. Maybe we had more privacy 20 years ago, before the mobile phones, before we had the mobile phones. Today's, all the governments have access. All the governments have access to all your data that you have on your iPhone. This is where the starting point right now.
I think that's, to be honest, I think that's a bit reductive, because what they do not have is coordinated accesses, and they do not have a single source of truth that's fully legible that they can easily run algorithmic analysis on. You know,
I'm talking about the blockchain. I'm talking just real phone.
Yeah,
Phones
that's what
are
I'm saying, that they
hackable.
don't have what I just said. They don't have that.
You have KYC. You know who you are. You know their phone, and they have. I mean, there is services right now. There is services that all the states can buy, and they just say, "I want to spy this guy."
We're talking past each other. What I want to say is there is friction. Governments can acquire information about an individual, but it takes effort. They cannot acquire all information about all individuals at low with a very low cost basis, and then perform a lot of analysis on it.
It's like they're using AI to organize all this information.
Okay, I think I'll bring it back and take us to a new question. But that's great from all the panelists. Let's go to Benedict and talk more about the technical side of things. So you've published tons of papers. You're working in both industry and academia. Could you talk some about like the balance you've seen between those? Like industry, at least in cryptography, actually seems to be doing in general a lot of work that doesn't start from academia, and how do the two work together?
Yeah, I mean, I think that you know, I think it's a complicated space, and I you know, sometimes I have the feeling, oh, like we haven't reached anything yet, and you know, we still have so much to do. But then there's things that make me incredibly optimistic. And one of the things that makes me the most optimistic is there is a beautiful synergy right now, and I think there's inherent reasons why that is, between academia and industry. We have really like cool ideas that come from industry that then lead to sort of, you know, more academic research, which then leads back into industry, and so on and so forth, and like hard problems that like people literally are expecting, like, oh, we have these hard problems, but we believe in science, you know, we believe that science can solve this problem, and smart people from wherever they are, whatever background they have, they can tackle these problems, and that's just so cool to see. And there's fundamental reasons why that, and it's way better than in AI, where like, you know, which is also an emerging field where academia and industry have a thing to play, but you know, their like data is private, right? And you know, access to data is really important in order to make, you know, even just new innovations and like certainly products. And one of the cool things about blockchains is that by its nature, it's open source and it's openly accessible, and you need to actually show that the product that you're building has value and is trustable, right? And that works so well with this academic model that we have. And like, yeah, so there's this, which is, I think, you know, also like, they used to say that like in the best case, it takes 7 years for some cryptographic innovation to be deployed in practice, right? And now, I don't know, like I've had, less than 1 year, right? It's like, or I think I wrote this paper, and then within like 7 months it was deployed in Monero, and you know, it's sort of powering Monero. And yeah, it's a really, really fun space to be in and to work in, and it makes me, like when you have both companies that are profit-oriented, which is totally fine, and smart people in academia working together and tackling these hard problems, that is what makes me optimistic that, sort of at least the technical challenges we can solve. And it's been like, yeah, it's exploded. And it's really, I cannot be more positive and optimistic about it.
Let me add to that. So I've been an academic for about 20 years, right? Mostly within an industry bent, but like I've been publishing papers for about 20 years. And frankly, I have not seen a space or have not experienced personally, like firsthand, a space that moves quite as fast as this one. And of course, AI is sort of competition that we have. But the level of sort of intermingling, the level of kind of exchange of ideas and the speed with which it happens here in ZK specifically is quite astounding, right? And again, I lived through a previous sort of wave of ZK innovation back around 2013, 2014, right? Had some interesting results back then too, but I mean, nothing compared to what we're seeing now, right? It's just like the speed at which results are coming out in the form of papers, right? I mean, like oftentimes we don't even bother submitting things; they just go onto ePrint or archive, and people read them within days, right? Or like the speed with which experimentation is happening, again, quite astounding.
Yeah, I mean, I agree completely. I think that the kind of the intrinsic incentives of blockchain are extremely positive sum in many ways, and it's an area where good ideas rise to the top because they're not controlled by like individual factions that are trying to monetize them. They just become another piece of a very composable framework where they add value to a lot of different projects, different people. And yeah, it's really positive to see. I think the quality of opportunities available to competent people in this space is so much greater than any other industry I've ever either been in myself or observed from the sidelines.
Yeah, I think we talked a little bit earlier about some of the political problems and sort of human rights issues that we hope to address with the technology. I was also an academic as a professor of mathematics before starting this company, and you sort of saw, I would say, 4 waves of turning math into money, right? Like, what are the options if you want to make a career outside of academia? And sort of wave 1 was defense, and wave 2 was maybe trading, and wave 3 was maybe advertising, and this is wave 4. And this is the wave that I felt okay leaving that academic job, because I felt like I could wake up and do something about problems that I saw in the world, and that the actions and technology that I was building actually could have a positive impact. Of course, there's a lot of froth. Of course, there's a lot of issues. But I think it's easier for me to sleep at night, I think, than if I had gone one of those other routes of turning math into money.
Jim Simons did very well in wave number 2, right? Or in the trading wave. Jim Simons.
Yeah, I think if we have one value that probably right now is in danger, and is this collaboration environment that we are in the space. Of course, this is why academia likes, because academia has been also always about collaboration on that. This is an important value. Here for me it's a call, especially to the tech people, to the people that's interested in engineers, people, mathematicians, people that's interested in the technology, to keep this value in mind. The pressure from the society, from the competitive, from the marketing teams, from the business teams. Money is money, and the pressure is huge. But here is a call, for technical people, for free technical people, for people that's interesting, to keep this collaboration. And this is, if we keep this is much better for the industry. It's even better for the organizations, for the corporate organization itself, okay? Because they been an evolution, okay? So we get, and we are in a blue ocean in this space. So this is even good from the business perspective. But one of the biggest dangers that we have in the space is that at some point we stop collaborating. So even if sometimes goes against your heart, we need to impose ourselves. Let's act as free persons and continue collaborating. Do not hide information. Do not hide technical information for patents, for business reasons, for whatever. Just share what your knowledge. And if we all technicals, we keep as that, we are going to advance much, much, much faster. And this value is important. And here I think that from the academics, that's if we keep this, the academics, they are already been doing that for years on that. We should be an example for other industries and keep this value as we have been doing until now.
I think, sorry, like, there's one, like while we're on this topic, there's one, like sometimes there's some small frictions between sort of academia and industry. And also, by the way, to your point, keep funding research. But it's one small friction is that, academics like to write their papers, with, like very formal, and they like to get their citations and brownie points. And the greatest trick we ever pulled is that, as society, is that we, get to underpay academics, but they get their brownie points. So keep giving them brownie points. It's very important. But then, technical people like to bring things out in blog posts very fast, just put the idea down. And I think both are great, and we need both. And I don't think one sort of like obliterates the needs for another. Only because, an idea has been written as a blog post doesn't mean that, someone else can, formalize it and write it in a much more, like formal way with mathematical proofs and all of that. And only because, something only because you have an idea, it doesn't mean you need formal training in order to publish it. If it's a good idea, just write it up in whatever way you can or care about, but put it out there. Just exactly as Jordi said, we need to keep this culture of open source, of open publishing. I think it's one of the strongest assets we have as an industry.
It should not be incompatible to be formal and to be clear and that accessible for the teams. I think it should not be incompatible. I know that sometimes you need to do an extra effort for compatibilizing both things, but I think it's, if crypto went so fast, and here I'm looking here people that wrote some papers, is because the people that wrote the paper, they not only did the formal part, they also did a huge effort to go a step farther in the paper and explain the protocol, explain the whatever they was explaining in an easier way for the people that are less used to read papers to to understand the basics. Maybe going after the formality, which again I respect, and it's important, it's essential in the crypto space.
Yeah, and it doesn't have to be the same person, right? I think ideally, you do everything. You write, formal academic paper, an informal blog post, an implementation and everything. But not everybody is suited to do all of that, right? Like someone might not have the formal training to write a perfect paper. That's okay, I think we can again use the power of collaboration to have, someone else can explain a paper. I think that's totally okay, and I've seen, and this is happening, which is great.
I think there is tons of willingness to go up and down the spectrum, and again, not everybody has to do everything, right? I think there is a lot of willingness to sort of do handoffs. Of course, people need to learn how to do it better, and this takes some time. But frankly, look, for years I worked in areas where, you have a paper, and then it takes at least 5 years to see any glimpse of that in production, right? Any glimpse of that, seriously. And so compared to that, things are happening blazingly fast. So that's one thing. The other thing is that I see a lot of willingness, even in the roll-up space, right, for people to do things together. And we are on the research team starting some collaboration with other roll-ups, and certainly we would love to see more of that, and perhaps eventually standards around some of these things. But at this point, let's just see more of that and see where that takes us.
Okay. All right. Speaking of collaboration, we have all of these super smart people on stage who are publishing papers and creating ZK VMs and ZK AI and privacy and crazy things. And we have all these wonderful people in the audience here who are just dying to know how they can end up like you guys at some point. So what advice can you give to the audience that they can start working on to end up helping with this future that we're looking for?
I can. Oh, do you want to go first? Or?
Go ahead.
I can give the cynical answer, and then I can give the real answer. The cynical answer is go to www.aztec.network and download our sandbox and start developing today. We've got a great grants program. And in all seriousness, it's amazing tech, hack on it. We've already had like several teams that have actually created startups out of what they can do with our tech. But more seriously, like, okay, the thing is, if I look at how I came into this space, I'm not sure it's a model that can easily be replicated because there was just a lot of serendipity and circumstance, right? Like I came into the ZK space when it was still relatively new. And I had basically, I didn't know ZK. I learned it from scratch in 6 months and was able to make meaningful contributions and publish papers. And that's not as easy anymore. But I can give more general advice, which is basically find an existential problem that speaks to you. Find a sense of belonging. Like if you're working on a project and you're getting as like intrinsic satisfaction from working on it, and you feel like you belong, you're in the right place. Keep going. And if you're not there yet, then maybe you need to explore other alternatives. But like you need that existential need to drive you. Because if you don't have that, you're not going to be prepared to grind the 20-hour days or whatever it is for multiple years and change roles, wear different hats, learn different skills in order to succeed.
Yeah, I can listen. I think what Zach said is very correct. I think it really depends on who you are. There's great academic learning resources out there. Coursera has a great and free cryptography course that teaches you the basics of cryptography. There's tons of YouTube videos on sort of learning about zero-knowledge proofs. There's obviously amazing libraries, that you can hack around with if that's what you do. Just starting to play around with. I think one thing that really, one advice that I would give is that it's really helpful to be comfortable with abstraction. So for example, not knowing exactly, sometimes it's good to dive deep and know exactly how something works, but sometimes it's also very useful to just know what it does. So for example, if you just understand what a zero-knowledge proof does, it allows you to prove that something is true without revealing why it's true. That's sometimes okay to understand everything you need. You don't need to understand how they work. Or sometimes I get people that come to me, it's like, oh, I started to learn about zero-knowledge proof, and then I got stuck at elliptic curves. And I'm like, I don't really know how elliptic curves work either. That's way deep down the line. You don't need to know that. You can sort of just be comfortable with some abstraction of it, and then just knowing how some things work, and then you can build on top of these things. But yeah, it's just. I think hacking around with a library is one of the best ways to start, and yeah.
Get your hands dirty. I mean, that's a problem that's common to everything. I would say the vision maybe from the developer, for people that loves coding. I mean, this is very much my passion. Just take some of the protocols. I mean, just try to create by hand an Ethereum transaction and send it to Ethereum transaction and see that it's mined and it's accepted. If we implement elliptic curves, if you implement this CDSA, if you implement numbers, the finite field, some finite field libraries, coding. I mean, just trying to understand by coding. When you code something means that you probably have a good understanding. Well, not always, but in general, in crypto, if you don't understand what you are doing, it's very much you probably will end up giving up. So for me, the way to get in the space was coding. It's coding. That's what I like to do. I think you can get a good level. Maybe if you want to write papers, then there is other path. Then we need more math, more abstraction on that. But I just want to share here my experience that coding and trying to understand what's going on, maybe studying a little bit of math to understand what's going on. This is the best way to get in.
So I can also do a plug for us. Of course, Well, one of the things we built was a system that lets you just write in Python. So you can just write in a Python Jupyter notebook. You can write ordinary PyTorch and compile it to an AI model, which is a zero-knowledge circuit. That's a great way to get started and play with it. Of course, I agree that the right way to do it is kind of play with the thing, start to think about what you want to happen. Very soon, you will reach the limits of the technology, because it really is a young technology, although it's moving very fast. And then you start to dig in onto what, how far down the rabbit hole you'd like to go in understanding, the kind of math you need to add. And that can go all the way to very deep algebraic geometry, right? So I started with algebraic geometry from Robin Hartshorn, right? And then somehow way down the Rhine, I find myself doing extremely applied algebraic geometry. So the math that underlies it is extremely beautiful, and I would encourage you to dig into it, but don't think you need to learn any of it to start.
So look, my take is that there already, even on this stage, there are people of fairly different backgrounds. My background is in systems, right, let's say, as opposed to cryptography. But as the space expands, I think there will be even more diversity that you're likely to see. I think what's important is that given how fast the space is shifting, is finding a large, long-term problem that really appeals to you, right, on a deep sort of psychological, even emotional level. This is the kind of thing that you're happy to work on for the foreseeable future. It really helps, because this is how this is what forces you to learn. This is what forces you to overcome obstacles as they come. This is what forces you to sort of reconfigure your forces as circumstances change and, things change around you, right? I mean, I don't know. The innovation in proof systems, we see like a new one being announced like every, 3 weeks or something these days. So, yeah, that's my take.
Cool. All right, I hope everyone is very inspired about the future of ZK now. I think that's all we have time for, so let's thank our panelists.
Yeah, that was fun. We got some controversial takes.
Hey everyone, we are getting ready for the next panel with our community. Just stay tuned for a few minutes and I will be back on stage.
That's really. All right, awesome.
My height. Oh, wow. Okay.
Yeah, do you mind helping me get this up a little bit?
Everyone can listen to me.
Am I loud and
first.
clear? Oh, that's perfect. Thank you.
Oh, hello. There we go. We
One,
have
two,
a mic
three.
check.
Yep.
I need to eat the microphone.
Thank you.
I think I'm good.
Yeah.
Front and center.
Yeah. Okay. Do you have a microphone for
I
questions?
feel like I'm
in
going to
case-
lick this. It's like,
You'll be able to do
I feel like
microphone
I'm
for
going to like
questions if you
accidentally.
want? All right, cool. If we got it, we'll see if we have questions. All right.
Oh, you're a pro.
Maybe we can join. Yes.
Kind of want
Do a little like. No, I need good posture.
Oh,
for this.
nice. Okay. I might just hold on to mine. I like fidgeting with my hands. Welcome, everybody. Let's get this show on the road. We'll stick right on schedule. My name is Braden, or BX Pana, from Matter Labs, the team behind ZK Sync. And you're joining us for the good, the bad, and the ugly to take the next few minutes to take a look at the good of the technology and achievements from different ZK rollup projects, the bad, some of the technical things that they've run into, and then we're going to take a look at the ugly and take a little bit, turn the stone of community and take a look at what's going on underneath it instead of just the shininess on the outside. So we're going to start off the segment, just a little introduction from each of our guests and let them just give a little 1 minute intro about who they are, where they come from. Go ahead, Alex.
Hey, my name is Alex, and I am community manager at Tyco. So I handle all things community, Discord, Twitter. I'm a little more on the ecosystem side, so trying to find really fun, interesting things for people to do on Tyco. And that's about it.
Hey guys, I'm Shariar. I'm on the partnerships team at Scroll. So if you're not familiar, Scroll is an open source, bytecode compatible, community first ZK AVM. We launched on mainnet in October. And in my role at Scroll, I work across a bunch of different initiatives like DeFi, staking, restaking, stablecoins, a bunch of stuff.
Yeah, hi, I'm Emily. I do developer relations at Linea. That means a lot of different things, so I can't tell about like my day-to-day because I feel like it changes like crypto. Yep. But anyways, Linea, yeah, we are an EVM equivalent ZK rollup, moving towards a type 2, eventually type 1. And yeah, where types thrive.
Hello, everyone. I'm Sisyphos. I work at Matter Labs, the team behind ZK Sync. I'm a community manager. We're focused mostly on the developer community right now and been focusing on the users in the last 2 years. And ZK Sync is a Type 4 ZK VM. We've been on mainnet since March last year, last ETH Denver, and I'm happy to discuss with all of you the good, the bad, and the ugly of ZK VMs.
Sweet. Thank you, guys, and we really appreciate you being here. And like I was saying, we just wanted to give an opportunity community to just have a little bit more of a say and show to the world of developers, especially at Beta Week here, what goes on behind the scenes. But before we get into that, I just want to make sure we cover, the technical bases. So we're going to start with the good. and just give you guys a minute to talk about, like, from the technology standpoint, what are the good things that you guys feel have been accomplished by your project or by your protocol, and like the future achievements that you guys are trying to achieve, what you guys are trying to do as well. So let's start off. We'll go switch up the order. We'll go backwards. So Esteban?
All right. Wow, it's been super exciting to launch the first ZK VM 1 year ago on mainnet, and that has been a great technical achievement. I think we were on mainnet before the whole Ethereum community was expecting to see an ZK VM on mainnet. So that was like something that was amazing to go through. More recently, I think one of the technical advancements that I'm super excited about has been our new prover. We published and is live on production the new prover called Buju, which decreased substantially the fees on ZK Sync, and I think since then we've been consistently able to manage, I believe, the cheapest fees as a layer 2, and I think that's an exciting technical achievement. I think Buju is also a great system because it has a very low hardware requirement. So when it comes to decentralization one day and having a decentralized prover network, having low hardware requirement is, I think, something that would enable to have a proper decentralized prover network. So these are the two technical achievements that I'm most proud and happy about over the last 2 years.
Nice, excellent. Emily?
Yeah, definitely a lot of really cool things about Linea. I think I want to speak more from like an ecosystem of technology standpoint. So if you guys don't know, Linea is powered, our circuits are powered by Gnark. So Gnark is an open source ZK circuit library that is the fastest snark on the market. And it's a Golang, and there's a lot of things to say about it, but if you've ever interacted with like ZKBNB, Seller, ZK Bridge, everything, like Gnark powers those, and it's like that's an in-house team with the that at consensus, right? So that's really cool. I kind of want to take the other view of like, again, leveraging ecosystem and open source projects. So Linea, and any of you guys call me out if this is untrue, is the only L2 that is multi-client, right? So we support Nethermind, Bezu, Geth out of the box. Which is really, like, I think a huge technical achievement. I can't explain how they do it. They're just intelligent people. But yeah, I think that's kind of something that people don't really think about at all. Especially when we keep talking about decentralization, multi-client security, blah, blah, blah. Like, ZK, yeah, I don't know. But anyways, that's really cool. That I'm really proud of our team. And I think a lot of it also is due to Bezu, right? Hyperledger Bezu is an open source team that sits within consensus as well. So there's a lot of synergies that we've been able to leverage from like the technical point of view.
Yeah, that's great. Thank you. Shayar?
Yeah, so there's a bunch of different things I'm really excited and proud about for Scroll, so I'll try to go through them quickly. One thing is like the cross-pollination of contributors between us and the Ethereum Foundation's privacy scaling and explorations team. So that means like our contributors are directly working on what we think is going to be the future of scaling Ethereum. That's a really exciting thing, and those people are also helping us out too. The second thing, I think, is that we have been pioneering the multi-prover approach. So just like you said, with client diversity, you need to have prover security for fault tolerance. So over the next few months, we're working on basically bringing, in addition to our ZK EVM prover, we're going to have a trusted execution environment prover that's going to be based on stuff like Intel SGX on a threshold signature scheme. So that's going to help build another layer of security on proving. And I'd say the last thing is that we've been working really hard on being really as compatible as possible and making it as easy for developers in terms of like opcodes, precompiles. And it's like a little known thing is, as far as I know right now, we're the only ZK rollup that has the precompiles necessary to deploy Noir contracts on Scroll. So that allows you to build stuff with privacy. So yeah, those are all really exciting things all over the place that I'm really happy about.
Fits in perfectly for our last panel that was up here with the privacy talks.
Yeah.
Thank you. Alex?
Well, where do I even start? I think Tycho's, it's a little bit different because we're still in testnet, so a lot of the interesting things that have been happening have been like a long evolution over like the testnet phase. So I think a big thing is Ethereum alignment. So everything about like being a type 1 ZK EVM, so we can really work with the existing dev tooling. We can work with existing smart contracts. It's Ethereum extended. And I think it's been a really long, interesting road with a lot of like open-ended research problems that we've had to tackle from testnet phase to testnet phase. We've tried out different like tokenomics designs. We've experimented with L3s. We've taken a look at like Scroll, like a multi-prover approach. So we have a based contestable rollup that we're testing out right now in our testnet, and so that's again similar along the lines where you can basically plug and play and use different proving systems in the rollup. So you can use like trusted environments like SGX all the way to the new up and coming cutting edge proving systems. And that's also been a thing, is like the adaptability of like Taiko as a protocol and how things have changed. The ZK world is very new and up and coming, so there's lots of changes. 6 months from now there might be a new novel proving system. And so I think a big key has been keeping the protocol adaptable and able to sort of be modular in a sense, so we're not relying solely on like one proving type. We're not, when things change, we can keep up with the entire landscape. And it's been really interesting to see us kind of like adapt to that really crazy landscape.
This is awesome. I just reflecting on when starting in the industry here, like where ZK was, to now hearing about multi-clients, multi-proofs, being a type 1, like having different proving systems is like, it's mind-blowing what we've done in the last, maybe 4 years. So just wanted to highlight that really quick. And of course, we talked about the good and the technical. So we've covered the good. Now, thinking about each of these great things that you've had, I want us to also explore like the bad. All of these, while we're trying to achieve like technical greatness, there's a trade-off with some of these things, and it's the challenges you run into or the trade-offs that you make or whatever it is. So just thinking about that perspective, what has been like the challenges from the technical side that you've seen for your guys' projects or for your protocols? And let's go ahead, let's mix up the order, make things spicy. Shayar, you want to start us off?
Yeah, I mean, where do I start? I think, so scalability and costs are probably something that we all have dealt with the growing pains with running a ZK EVM. I mean, like if you go to any like Twitter announcement, probably from any of us, and look at the first few comments, it's like, please reduce transaction costs, please reduce bridging costs. You just got to deal with it. I think with ZK rollups, the thing that people have to understand, obviously, is like initially the prover costs are going to be amortized over fewer people, but over time it reduces as you change the prover scheme, as you change and adapt the circuits, as you optimize those contracts and everything. It gets a lot cheaper. But at the beginning, you can't expect the same experience you're getting from optimistic rollups. And so getting over that bridge of understanding for developers and users that it's not the same user and developer experience at the beginning has been the biggest challenge for us. And I would say, just like you said, continually adapting to this this ecosystem is really difficult, right? Like these circuits that we build to prove these particular opcodes and precompiles, we have to continually adapt and upgrade them. If you ever want to change the prover and verifier scheme, we have to adapt that. We have to also make them simple enough that they're auditable. And if we want to add any of this custom stuff that's part of these new narratives, right? Like the modular narrative, you get an alternative DA later, you have to prove that too. So there's this like constant push and pull of trying to keep ahead of the narrative and keep the same UX and DevX of incumbent L1s or L2s that have had time to catch up and get that existing user base. But I think, I'm very positive that we're getting over that inflection point now.
Nice. All right. Emily?
Yeah, I guess there's kind of two ways to look at it. Like, I think generically bad is just trying to build a ZK EVM, right? There's a reason we came out later. I think like, at least the Linea team has taken a really interesting approach to it in the sense that it used to be 2-step, now it's 4-step proving system, where kind of the translation part of the proofs, we actually just didn't do a snark. It's something called lattice-based hashing, where it's really good for recursion. And then at the very end, it's kind of too big, and then we like shrink it down to a snark and whatever. That's probably not the important part. I think I want to talk about like the comments on Twitter and like what that means in terms of the bad. And I want to speak specifically to like, I think, the user, like trying to explain gas prices to users, especially since at the end of the day, we are still affected by L1 prices. And so like, yeah, if everything is pumping, like Ethereum's expensive, whatever, and like that's gonna affect us, right? Like as L2s, I'm sorry, yes, the fee will get higher. And it's like trying to manage the, the community of like explaining how gas works to like a very technical thing to a non-technical audience, many of them just aping into the, the chain and things like that. But I think probably the solution to that is just making everything cheaper, right? Like, whatever, okay. Which is exciting, right? Because I think from the Linea perspective, we did introduce data compression 2 weeks ago, which reduced our prices by 66%. just pretty like hefty kind of. Yeah, and I heard Scrolls kind of be doing something similar soon.
On the way, soon.
Right? Yeah, which is great.
Very cool. Yeah, the YOLOing for some people who just yeet right in. You're like, let's take a step back. That's the one.
So I'd say that the explicit trade-off that we're making with ZK Sync is a performance equivalent one. So we're not a EVM equivalent ZK VM. So I'd say I would classify as the bad as being like there is an additional barrier to entering the ecosystem. You have specific tooling. You have to adapt a little bit. There is a little bit additional work for you to onboard on ZK Sync, and that's one of the main, I'd say, bad aspect that we saw. But we are actively working on it to bring better tooling. Tooling on which normal devs are familiar with. So yeah, I'd say that has been the main challenge, is that we had great performance at the protocol level, but at the expense of a bit of equivalency. But we're working actively on that and making the developer experience as smooth as possible.
Yep. That's definitely a big challenge for us. Tycho, Alex.
Well, it's been, a long road. I think being Ethereum equivalent and being like a based rollup basically just comes with its own field of like future research questions. So again, this whole landscape is really experimental. A lot of these like protocol designs in general, like design spaces, are really unexplored. So it's a challenge of seeing which direction is the right way to go, where to put all of your energy and what to focus on, because these are all questions that people haven't answered before. This is the first time, we're taking this on. So it just takes some time, and it gets a little difficult trying to figure out, again, like the best way forward, because there's 10 million and one ways to like figure out a way to design this protocol. But I mean, those are happy and open challenges. There's been lots of like collaboration between like the Ethereum Foundation and researchers, like he mentioned with Scroll. Tycho was also working on that like open space collaboration with like the privacy and scaling exploration team on like the ZK EVM circuits. So there's research being done on like based pre-confirmations. Justin Drake is talking about shared sequencing and all that, and there's multiple ways to go around that. There's a million and one questions to answer, and I think the biggest challenge is getting around to all of those. And another less technical but more like prominent like challenge is just expectations. You have this like really opinionated like Twitter community, for example, that you always feel like you're on stage. Like everybody's like waiting for you to make the wrong move so they can make their Twitter comments, and so you always kind of feel like, whatever step you take, you're always thinking about like, what could people say about this? What could go wrong? So it's those expectations of always feeling like no matter what you do, you're always going to like let somebody down, whether it's with an airdrop or, the direction that you're taking the protocol, whatever, people have really, really big expectations. So trying to supersede that and to make the most people happy, I think is a really big challenge.
Yes. And you're right about that. It's like all of us, in a sense, are all like building in a glass house, and it's everybody from the outside who has something to say about what's going on in the glass house. But like we're the ones in there. But everything you do is always on stage, and like that's definitely something that's different about this about crypto that I enjoy, and is also a bad. So good and the bad. Okay. Well, thank you guys. And now let's talk about. So let's look into the ugly side. Like we all know that community is a wonderful part, an extension of a crypto that makes really why most of us are here. It gives the soul aspect to Web 2, gives the ownership, it gives this like camaraderie of a place of belonging. Now we all know those are the good parts, but what's the ugly side that like you're just like makes you like, why am I doing this? Like then you get back and you're like, all right, yeah, this is what I'm here. But what just like drives you nuts? What's the ugly side of your role? Because I know not everybody is community leads here, but in different like facets of the community. But what is the ugly side that drives you nuts? And this one, let's go with whoever wants to start. I won't force this on anybody.
I can start off with that. So being a community manager, I'm like, all in on the community. So that's my day-to-day. And it is a really like crazy space. You know, it's almost like the elephant in the room. You know, you have like, you know, we're here in a builder's hub. Everybody's focused on protocol, technicals, you know, ideas, building stuff. You know, and the community is just kind of like they're off to the side. Where, you know, a lot of people don't even want to touch it. They don't want to look at it. And I think, you know, you're referring to it as the ugly because, you know, I've even noticed in my space there's like this like airdrop farmer type of like, you know, vibe. There's people that don't really care about the fundamentals, that, you know, they don't care about being part of a community. They're just in, out, try to get whatever they want, you know. Lots of back and forth about like, oh, this is better than this is better than this project is going to win, you know, you have to be a maxi on one project. Yeah. And so I guess I have like a unique perspective. So like with Tycho, I started out as just like a general community member. Like I was just interested in Tycho. Like I didn't know anything like super technical. You know, so I was just in there asking questions. You know, our engineers took time to like talk to me, answer my questions, gave me enough knowledge so I could personally go out there, you know, on our Discord server, answer questions to other people, you know, really inform people about like, you know, how to run a node, you know, what's going on with the protocol. Mm-hmm. And then from there, you know, they really cared, you know, they gave me a moderator position, and then from there, community manager. And so I guess I have this really like personal, you know, interest and like stake in building like a really robust and interesting community. So I think like a big challenge and a big key has been trying to stray away from like the financialization of like a community. And so it's kind of banking off of that ugly. So it's like you have people that, you know, join your Discord server, join you guys on Twitter, you know, for whatever reasons that they have, you know, potential airdrop, this, and that. But people are just there. They're in your community, and it's how you foster that. So what we've really tried to do and what I've really tried to do is foster that environment that I was given of like education. So, you know, people have joined, you know, our Discord server. They've never opened a terminal before. They've never installed Docker, you know. And then within a few days, you know, they're there like running a node, running a proposer, you know, answering questions for other people, and people get really excited. So we've seen lots of like community initiatives and like projects where people start, you know, we've had our own community built like prover network where somebody was just like in our community asking questions, and they were like, oh, hey, I could build like a distributed prover network. And that was all community run, you know. So there's been some really beautiful like projects and like initiatives started just from our community, because it's really been all about like cultivating. You got people there for whatever reason that they're there. It's all about, you know, treating everybody with like respect, you know, giving them time and really showing them that like you can learn. It's all about education, you know, really giving people the time of day to like foster that like environment.
Nice. Way to take the ugly and then make it beautiful again. Like, see, it's like it's so hard to make community ugly. All right, so I'll leave it up for the next person who wants to take it.
Yeah, I could take it. So I think there's two ways I can say. Like one, and I think this is like a one-sentence thing. I absolutely hate how everyone calls it an L2 war, which is like the dumbest thing ever.
Yes.
It's not a zero-sum game. Like multi-prover, I guess Linea is the only multi-client one, but no, I'm just kidding. Yeah, so stop that. That's ugly. And I think I want to touch a little bit about the financialization of community. And I think, actually, what I think is really ugly is, I don't know if you guys feel this, but I feel like there is an element of developers like pitted against users, Sybils, farmers, right? Because, you know, like I think there's an extent of like, oh, we worship the developer, we worship the builder, which is true. Like they are the ones who build the future. But I think what Linea has done, and I really like from like an L2 perspective of the opportunity that we have, is we have a lot of eyeballs, right? And also, I mean, like, where do those eyeballs come from? So if we look at the the uni drop, right, that's like average $2,200, which will feed, what, 44 people in Vietnam for a month? This is like life-changing money, right? Which is insane. And so you have a lot of attention. And so like L2s, we have this opportunity to direct the attention back to the builders and say, like, let's spam your network. Your load balancing needs work, or like your UX is really bad, and stuff like that, right? And like also from like an L2 ecosystem perspective, right? We are connected to everybody. We are connected to users, builders from the developer level, like developer tooling, builders from like, I don't even know anything, like you mentioned as well. And there's so much like capital that we can do and interact with people that I think is ugly, the way that we kind of I call it like, don't villainize the farmer, because they do a lot for us at the end of the day. And I guess the thing that is ugly about them, I'm very fortunate I'm not in your position of community manager. I'm going to be honest, but I talked to them. And it's ugly how nasty internet anons can get.
Yeah.
So please be kind. I'm sure none of you here are mean in DMs. Hopefully not. Yeah.
Cool.
So that's where I'm at.
That's, yeah, they can be mean. That visible wall behind.
Yeah, I'll say that I agree with all of what you said, whether it's managing the expectations within the community and channeling the attention that is not necessarily focused on the protocol towards the protocol and the mission that we are trying to accomplish with the ZKVMs. I will always remember the first time that we tried to just innocently run a survey through the community, and we had like 15,000 people just sibling the form, all the infrastructure going down in between, and we were like, yeah, I mean, this is not, I mean, essentially, this additional burden from, the community trying to game protocols and the protocol trying to leverage and farm the community, these adds a lot of additional operational burden for us. And, if you want to run a meme competition, if you want to run anything in which there is a minimum at stake, you need to think twice about how you're going to have, on board, what pipeline you're going to have, because that it's going to be Sibyl, and you have to, take the necessary steps to account for that. So, high expectations from the community creates also high operational burden on our side. So, that's it. I would say that was a bit the ugly side that we faced over the last 2 years. But of course, the sometimes how mean the community can be, but also how good and altruistic they can be. I think that comes with the job. Like, we have this broad range of community members, and sometimes there is a very minority fringe that could be very vocal and mean sometimes. So,
It always seems like a constant fight sometimes. Like, they change something, so then you change something, and then it adds then they change it this way, and you're like, I thought I already stopped that. So it's like this never-ending cat and mouse, I feel like sometimes too. Shayar?
Yeah, I mean, I agree with all the points you guys have made. I think there's a lot of difficulty in finding the fine balance between respecting and listening to your community and then kind of focusing on this vocal minority and bending your will to them sometimes. And there's been a lot of discourse, obviously, about the toxicity of some of the community members and a lot of different reactions across the board. I think my take here is that it's a no upsides move to disrespect or look down on the members of your community, right? There's ways to work around it, and there's ways to focus on the people that deliver the most value. But looking down on them, on people, like you said, who for this amount of money is life-changing, it doesn't help anything. And it just makes you seem a lot more highbrow and thinking you're above them when, we're trying to all be very down-to-earth people. And then one other point about developers I think is also really interesting is that we, like you said, we sort of like worship the developers in a sense, and we think a lot about them. Of course, for us, like developer education and thinking about them is the most important thing. But sometimes we silo in on thinking about their needs only. And when you talk to them, they're like, wow, you guys are so compatible. It's so easy to build these contracts. But you don't ever listen to like users. Like, I want something fun to do. I want to just like be able to gamble with my money. And that might sound trivial to us, but this is a large proportion of what the crypto community is. And I think all of this posturing about trying to be super developer or research heavy, that has to be balanced with a little bit of degen and a little bit of understanding where the community members are at and what they need. That's my take on it.
Awesome. Well, so we got through the ugly, and when we were talking about these things, it made me think of something else. Like, not a lot of people, or when people think about community, they kind of just automatically put it into this subcategory of marketing or of growth, and that's what it is and has been in the traditional Web 2. But Web 3, I see it as completely different, as what we were talking about earlier. How do you guys manage like the internal expectations at your own companies of like, we see, I think from all of us, all of our mission statements or our visions are like community first, community built, community, community, community. But it can feel like sometimes inside, like you were saying, like it's something off to the side. Like, all right, we've got this vision, we got this, and like, oh yeah, and community's doing something. So like, regardless of your role, because I know you guys are in different extensions, but like, how do you convey how important like either community or what your role is to internally to your community, your company, so they know that resources need to also be put there. Like, product and everything else is very important, but yeah, community, DevRel, product or partnership, like all those need attention too. So how do you say, hey, look at me, like and down here?
Any order?
No, any order. I'm down.
I'm happy to go first. So I like to think of, I mean, a community. We always say that community Web3 is community first. Essentially, I think the reason why is that there is a protocol supposed to be owned by no one else but than a distributed community, and so you know. The same way that a protocol requires a certain level of engineering, and at some point there is open sourcing and there is a community that gets involved, I think the community also needs a certain form of engineering. You need to design it to be able to have contributors. I think have contributors, have specific opportunities to shine as well, and having the community being engineered. And talk the engineering language to engineers, I think, and see the community as a product that needs to evolve in few cycles. I think this is a way a bit to speak the MEM language with the engineering team. I think that's a barrier that I've seen, that speaking different language, the marketing language versus the engineering language, and turning that into a common vocabulary is a good way to advocate for what you want to try to achieve.
Well, I think, like, the way I look at it is, you could build the best protocol out there that has all the best fundamentals. You could have the fastest proving times, cheapest fees, whatever. You launch on mainnet, and if you don't have a community, you don't have any applications on there or anything, it's just a ghost town. What's the point? What's the whole point of building a protocol that doesn't have anybody a part of it? Without the community, the protocol is really nothing. And there's a real utility to having like a really robust and like excited community. It's like you can like blend the community and like the developer side together. So like, for example, like from my personal experience with like, community building and all that, we've gotten to a point where we have a pretty large and excited community behind our testnet. And right now, I'm basically utilizing that community to be a launch pad for all of these new and exciting applications that are being built on Tycho. So it's actually enabling all of these small-time projects that usually wouldn't get enough traction or have enough users to go through and QA test things and get feedback and all that. Having our community there and excited and like ready to learn about stuff and like mess around with stuff on chain and all that has really like fostered this like really incredible launchpad for like our ecosystem projects. So our developers on that side and our ecosystem, they all come together and they figure out like cool ways to like be composable and build on top of each other, and then they learn from stuff, and then they get valuable feedback from our community, and they have this really great like developer experience all from our community. And again, it's when you focus on the non-financial aspects of the community, when you get people excited. It doesn't even have to be like really complex like applications that are deployed. It's like people love to play games. People want to like play games on chain and all that. So you'll have all these projects that come on and they have these new fun novel ideas, and you're able to again bring community and developers together to create this really cool like experience. It's really interesting.
Yeah, the modular system all over again, right? Put things together.
Yeah, I think the point you made at the beginning was exactly right, where you said these are like all extensions of each other. It's really a question of internal structure and culture. Like we see, and I'm sure all you guys feel the same way, partnerships is an extension of DevRel, and DevRel is an extension of community, and community is an extension of marketing. All of them flow into each other, and especially in Web3, they all have to work together very tightly in these like fast iterative loops. I think that's how you get attention on community feedback. Like comms will highlight one thing, and then that comes to DevRel, and we say, okay, is this a technical issue, or is this an issue with a particular project? Does partnerships need to step in? If DevRel has an issue, they bring the rest of the team in. So it's really about highlighting the issues and making sure that every single team member who might be relevant is able to see it, and basically create a culture of like, okay, community feedback is critically important, just as important as an engineer's feedback might be in a sprint. That's kind of how you create a community-led or a community kind of feedback-focused culture.
Nice, that's really good.
Yeah. So I feel like you started off the question saying that I guess people don't care about community or it's off on the side, which I feel like is categorically false, right? Am I putting words in your mouth? Because that's like kind of the first impression I got.
It comes in both. It's like a dual. Sometimes like people come in and like, yeah, I'm here for the community, but I think you sometimes get to maybe more some projects who are like internally outside they're like, yeah, all about the community, but internally it's like, like community we'll get to it or whatnot. But I think a lot of people might like what I run into is some people will be like, oh, so you do marketing, and it's like, no, I don't do marketing. And maybe it's not just internally, but it's also like from the external people's like viewpoint. When they think of a community thing, they're like, you're doing ads, you're like a brand ambassador, like doing those types of things. So I guess something in that realm that I mean.
Okay, cool. I guess maybe because we just have like different maybe opinions on what community is. Like I don't think, like at least for us, our community team does not sit on the marketing team, right? But I think what I will say about community that isn't brought up, that is really difficult to navigate in terms of maybe like resources from like a time perspective, is how diverse the community is in regards to their needs, right? Because user community is completely different from what a developer community needs. And when like all of our teams are really small, right? Like how do you dedicate time to like, I need to take care of my user community while at the same time taking care of my developer community, somehow collating all that feedback and then letting like the product managers prioritize that. And then like even within the developer community, it's split into two groups too, right? Because you have the dApps who are wanting to deploy on mainnet, and that's like partnership side. And I think in general for a chain, that's usually your first priority, because when you launch, you want people to actually be able to do things, right? But when you start focusing on that, then you start to neglect individual developers, people just exploring the space, trying to figure out what's going on. And then you're like, okay, how do I figure out all this like mind share? And I don't know, I think the answer is always just hire more people, to be honest. There's not really a good answer there. Either overwork people and burn them out until they leave, or like hire people and care about their work-life balance. But I will say, I think from like the Linea perspective, community has been like critical, I think, to especially how we've developed the idea of how we interact with users, specifically like farmers or people like that, expecting incentives, and how important like transparency is about what's happening at the time, how like every action or time resource thing that you contribute will actually like manifest later on. Because I think when you pull the rug underneath people who are spending their time, like building with you, like transacting on you or whatever, like I don't know where I started the sentence, but the point is like it's something that you get a lot of feedback on from the community, and like addressing that and making sure they're feeling taken care of and heard and like understood that they are the core of your protocol is super important. And I don't think that's a marketing function, and I don't think that is ignored, at least like across the board. I feel like we're all here pretty nice.
That was exactly what I was trying to get across, so that you led into it perfectly. So thank you. We have just a few more minutes left. I wanted to just leave it open for a few questions from the audience, if anybody had any of the more project-focused questions or community-focused questions. If you've got a question, give that hand a nice high raise, and our lovely Albie Codes will come give you the microphone. Give it a little wait.
Questions for the communities? I know it's been a long day.
Oh, we got one right there. The guy in the beanie.
Hey, question. How can these unique communities all kind of connect and work together to kind of solve some of the bad and the ugly that was discussed on stage?
Ooh. Who wants to take that one?
I mean, I guess I'll say, I don't know if it's like, there is an element of we are all suffering the same problems, and I want to say just from like a perspective of working at Linea, it's actually a very collaborative environment from like the L2 side. Like we're all working together and thinking about how like we're solving problems. And I think in the same way, like each of us are figuring out what to do with our communities when they are ugly, and when someone fixes it or does something cool, one of us immediately copies it, which is fantastic. I think so, and that's what you're supposed to do, right? Like, like copy paste other people's success, I think is the way to kind of bridge the ugliness away. Yeah.
Yeah, I'll add to that then. We are working also with slightly different tech stack, and so at some point at the engineering level, I think there should be a certain level of standardization that will also bring these communities together. We maybe make the protocol more interoperable. We know already that our communities are, I'd say, overlapping. We're all within Ethereum, but it's true that there is technical differences that at some point over the long term, I think we're going to naturally converge through a specific design architecture that will also bring the communities together.
Yeah, I would say, like, for the community members, like, I think there's this like idea, this like L2 war. It's like complete BS. Like, all our teams know each other. A lot of people probably could have or might have worked at other people's teams. Like, there's a lot of overlap. There's like no war happening over here. So I wouldn't think about like pitting L2s against each other. It's like L2s against the world. We're trying to grow the pie. Like, just try out everything. If you have ideas for interesting applications, try them out everywhere. Get engaged in each community. I think, yeah, the pie that we're trying to grow out is a lot larger than what we're fighting for right now. So just be actively engaged in what we're building right now, and I think it's going to be really exciting in the next like 5 to 10 years.
Yeah, and I think I'll go a little bit of a different way. I think it's just like what I try to do with like my community is just remind people that it's not a big deal. Like it's chill. It's like, you know, it's not like life or death, you know, like there's no L2 war, there's not this crazy like, you know, end game or whatever. It's like a really open collaborative like research space, you know. And so I guess when things get a little ugly or a little bit crazy, it's just, you know, we have like our weekly like community calls and we talk with our community, and there, you know, it's really like getting that message across that like, you know, these things aren't serious. It's not life or death. You don't have to pick one over another. It's just like, come check out what we're doing. We're doing cool stuff. You know, if you like this better, you know, that's cool. But, you know, we're always around. We're always here to help you guys, teach you guys, you know, be a launch pad for your project or whatever. So, yeah, again, we all have overlapping communities. So I think it's just reminding people that it's not so serious all the time.
Yeah, that's great. Well, thank you guys all again for your time today. We really appreciate it. And I just hope that there was something great takeaway for people in the audience as well. Just wanted to showcase that the community, as much as the rainbows and the fun and the unicorns that are out there, there are different sides to it. And there's also this deep complexity level of knowledge that I'm super impressed that a lot of people think that community can be a little bit higher level. But when you're in it, you're cross-functional, you're going between different departments, so you're absorbing the different knowledge along the way because you are the first like part of the funnel of people coming into the community. So you have to have that layer of knowledge to help them along. So thank you everybody for participating in the good, the bad, and the ugly, and thank you for everything you guys are doing for the Ethereum ecosystem. We really appreciate it.
Thanks for having us.
Thanks.
Thank you.
Thank you very much.
Yeah, it was fun.
Thank you for coming.
Speaker notes?
We are getting ready for the next presentation, which will be our final presentation for today. Stay tuned for like in a few minutes. Zach will start with an amazing topic that we are all excited about during these times. Test. We are back with the last presentation by Zach, who's a senior protocol engineer at Matter Labs. He'll be talking about AIP 4844 shard blob transactions, aka proto-deng sharding. Let's give him a round of applause and let's have fun. Thank you.
All right. So yeah, I'm giving a presentation on 4844. So who is familiar with blob transactions? Okay, perfect. I saw someone pointing at me. Thank you. Be kind of awkward if I wasn't. So yeah, basically we're going to go through an overview of what 4844 is, what are blobs, how does the blob transaction lifecycle differ from the normal transaction lifecycle, introduction of the new fee market, what changes we had to make to ZK Sync, and then what is going to follow. So the TLDR is blobs are cheaper storage on Ethereum. So before blobs, we mainly stored pub data in the form of call data. And then with blobs, we're now able to store it in an area that's relatively cheaper. The back of the napkin math says it's about 93% cheaper when it comes to the amount of gas that's being used. So as many of you may or may not know, Ethereum roadmap is moving to be rollup centric. And so that puts an emphasis on data availability. So 4844 sets the stage for this with full sharding while allowing rollups to take advantage of cheaper data sooner. So in the blockchain trilemma, Vitalik basically put it as a blockchain can only accomplish 2 out of the 3 kind of like sectors: scalability, decentralization, and security. We have those targeting decentralization and security, like Bitcoin and Ethereum, multi-chain ecosystems going for decentralization and scalability. But with rollups and becoming a rollup-centric roadmap, we can actually offload the scalability down to the rollups. So Ethereum would only have to focus on decentralization and security while allowing rollups to really put an emphasis on the computation. And now, so how do blobs kind of roll into this whole thing? So with blobs, we have the new storage type that's cheaper, but it's only, the reason it's cheaper is it's only being kept for a short amount of time, around 18 days. And now you might be thinking this becomes a problem, but for many rollups, 18 days is more than enough. Zero-knowledge rollups will really utilize this data within an hour or so as we prove blocks, prove batches to be valid on ZK Sync an hour after they're committed. And then on optimistic rollups, that data is only needed for 7 days, as that's the time for the fraud-proof challenges. And now each blob is able to handle the amount of data that we have in call data. And given the new targets, we can actually fit 3, there's a target of 3 blobs per block with a maximum of 6 blobs. It's not a ton right now, but this is really just setting the stage for full dank sharding that will introduce up to 64 blob slots. And it basically allowed Ethereum to move the necessary changes for the consensus and execution layer to now, while allowing full dank sharding to be focused on later. And that covers data availability sampling, so each of the consensus layer nodes doesn't have to hold each individual blob, which would add terabytes of storage for them. And in addition, there's the introduction of the multi-dimensional fee market. So it is really just like a complex way of thinking or of saying the way that blobs are being charged for changes versus how normal transactions are being charged for. So if you're used to gas going high for an NFT mint or an airdrop or anything along those lines, those won't affect the amount of cost that the layer 2s will incur, because the market for blobs changes differently than those for regular transactions. So we can go into the blob lifecycle. So when a user submits a layer 2 transaction, those get basically sent to the rollup operator, batched together with a bunch of different transactions for everyone, and then sent to the layer 1 mempool. Once they're in the layer 1 mempool, they get split off into the execution layer payload and the consensus layer payload. Blobs only being available on the consensus layer payload, and on the execution layer, we're able to get a commitment to the blob. And that's how we can ensure that we know what data is in there. It's the same data that we assume, and it'll help us reason about it in the future. And so this is another diagram kind of going through the life cycle. I think it actually does a little bit better job explaining how things get split up. So as you can see on the top right, once the execution payload and the blobs reach the beacon proposer, they get split up into the sidecar, which is the KZG commitment, the blob, and the proof that the KZG commitment references the blob, and then the execution payload, which is everything, including the hash of these commitments, which we'll go into a little bit later. So now, if we don't have access to the blobs on the execution layer, how can we reason about what's inside the blobs? And that kind of sets the stage for KZG. So KZG, which stands for Kate, and then I should remember the other two, but it's the last names of the 3 people who came up with this zero knowledge proof. And basically, it is a way to form a polynomial commitment of the data. And so if we wanted to know what's in the data, we could just hash it. And then on the execution layer, we could just have a hash to that data. But once we want to reason about what's inside that data, we would have to then provide the full preimage, which would then be inefficient and basically removes the benefits that we get from the KZG commitment. Instead, we can take that data, form a polynomial, and then basically make the commitment to that polynomial. What that allows us to do is we can prove what the data behind the polynomial commitment is by making a proof of, by evaluating a point in that polynomial and basically saying, I know that the value at this point is this value. And over a certain number of points, you then become more and more sure that the data in the blob is actually the pub data that you're committing to. And so the benefit of these commitments is they're significantly smaller than blobs. So for instance, a KZG commitment is about 48 bytes, whereas pub data, which is the main reason we seal a batch on ZK Sync, goes up to 125 kilobytes. So that is significantly cheaper, and the people who end up seeing the benefit of the reduction in this amount of data are the end users. And so I spoke about kind of how we take the KZG commitment and how we are able to prove what data it is, and this is done through a proof of equivalence. And with the proof of equivalence, we basically, on-chain, we're able to take the version hash from the execution payload. We use that along with the opening point and the opening value, and the proof that that the version hash corresponds to a KZG commitment that, when opened at the opening point, will yield that opening value. And with that, we're able to then prove everything we need to know about the blob. This is, for those who are a little bit more mathematically inclined, this is Vitalik's post on how the proof of equivalence can work. And so we started to talk about this multi-dimensional fee market and how blobs are being priced differently than normal transactions, and how this helps when ETH gas price surges. And so with that, they operate kind of like the EIP 1559, where once we hit the target number of blobs that we want in a particular block, the gas price will increase by 12.5%, and when a block has less than 3 blobs, we'll actually decrease it by 12.5%. And this makes it so that we can always be sure that we know when our transactions will get included, and when there's a surge in the normal, when there's a surge from demand for either, again, NFT mints, airdrops, the rollups don't have to pay for this burst in data, nor do they have to delay sending their L1 or their L2 batch commitments, waiting for the burst price to go down. So this is talking about the block size. So as we can see with proto-dank sharding, we have an average case block size of 375 kilobytes. And the real reason why proto-dank sharding was introduced wasn't necessarily for the average case, but you can see how in the worst case, the block size is actually significantly less than what we see in the status quo, which is using call data, or versus a different EIP, which was introduced, 4488, again, not to be confused with 4844, which would essentially, rather than introducing this new, cheaper storage, actually would reduce the amount of cost that call data would have. So now, the most interesting part, how does this all translate to ZK Sync? So in ZK Sync, basically, the way it works is we have our security rooted in proofs, and you can think about our L1 batches as going through 3 major steps. We commit the batch, we prove the batch, and then we execute the batch. And so when we commit the batch, we make changes to the batch commitment now to include both the pre-image of the blob that we're using, as well as we add in the blob commitment. The blob commitment has the version hash, the opening point, and the opening value as parameters. And so these values will then get included in the overall batch commitment and proven later on within the prove batches step. And so with going from call data to blobs, as I mentioned before, we actually bring it down the potential 120 kilobytes to 144 bytes per blob. And our system will handle 2 blobs, so that'll be about 288 bytes, which allows us to have double the number of pub data than we could previously have. So that means with more transactions and more state ifs within the batches, our overall cost will go down per transaction. And another important thing that we wanted to include within our contract changes was not just this ability to utilize blobs, but in the event that the blob fee market decides to go haywire, we want it to be flexible enough to switch back and forth between blobs and call data. And so this allows us to basically retain the finality that we currently have while giving us the flexibility to either opt for cheaper transactions or for, yeah. And so with the batch commitment, we also have to make changes to our prover, which basically creates the changes that we've done in the commit batches step. And so within our proof system, we'll basically take the blob, we'll repackage it we'll take the pub data, package it into our blobs, compute the KZG commitment, along with that, the proof that of the blobs. So so the fact that the KZG commitment references the blob, and that using these blob commitments that we've introduced in the commit batches step, that these are actually the values of that, and proving that and proving that all these values together will essentially give us what we've committed to on layer 1. And so going into what's next, for ZK Sync, right now, as I mentioned, we support 2 blobs, but in the future, we plan on supporting any number of blobs as the number of blobs overall supported per block increases from 6 to 64. But also with danksharding, we have more blobs coming, the implementation of data availability sampling, so each individual node at the consensus layer won't have to store all the blobs, but can just store a certain part. We'll have proposer builder separation, which is needed for increased security around different things like MEV, as well as a new 2D KZG scheme. And so I think we have a little bit of extra time left. If anyone has any questions about blobs or anything about that. All right. Oh, I see hands up there. I'm sorry. Oh, so the question was, who is going to be blob ready on day 1? So I can't necessarily speak to the other chains because we're not 100% sure what their progress is there, but I can confidently say that ZK Sync will be blob ready on day 1.
Nice. Thank you.
All right. Thank you, everyone. And yeah.
Well, everyone, Zach was presenting as the final speaker for today. I invite you all to connect and come talk to our team. We'll have like a few minutes here to network, and thank you everyone for joining the first ZK Mini Summit. Thank you.